Yes, sir. Yes, sir.
Audible?
Yes, sir. Audible.
Yes, sir.
Yes, sir. Yes, sir.
नाही म्यूट नाही केलं.
Very good morning to distinguished speakers, delegates from industry and academia, respected principal sir, faculty members, and my dear students. On behalf of Yash Institute of Pharmacy, I welcome you all for 3 days national level webinar series on trends in pharmaceutical science and research, jointly organized by Research, IQAC and IIC. I heartily welcome our eminent speakers of today's session, Dr. Pramod Khedekar sir, HOD, Department of Pharmaceutical Science, Rashtrasant, Tukdoji Maharaj, Nagpur University. Dr. B. Geetha ma'am, Professor, HOD, Department of Pharmaceutical Analysis, Sri Abhirami, College of Pharmacy, Coimbatore, for accepting our invitation and enlighten our delegates. A warm greeting to our guest of honor, Dr. Vinayak Deshmukh sir, Joint Secretary, Mula Education Society, Sone, for encouraging and motivating always. Kindest regards to our principal, Dr. Sachidanand Angadi sir, Yash Institute of Pharmacy, Aurangabad, for supporting and encouraging our organizing committee to organize this national level webinar. Thank you to have intellectual and curious audience today, and I am sure that you all will find the webinar engaging and extremely helpful. I would like to mention that we have overwhelmed response to this webinar across India. With this great enthusiasm, we will move ahead. Now I request Mr. Abhay Joshi sir, IQAC cell in charge, Yash Institute of Pharmacy, Aurangabad, to highlight the theme of this 3-day national level webinar series on trends in pharmaceutical science and research. Over to you, Joshi sir.
Thank you, madam. So, good morning, all of you. Honorable Joint Secretary, Mula Education Society, Sonai, Dr. V.K. Deshmukh, sir. Our beloved principal, Dr. Sachidananda Angadi, sir. Honorable speakers, Institution Innovation Council Coordinator, Mrs. Dipali Kulkarni, madam. Academic in charge, Dr. Vandana Patil, madam. ISO Coordinator, Dr. Gajanan Vaishnav, sir. Research Cell Coordinator, Ms. Rekha Gajre, madam. My dear colleagues, honorable dignitaries, participants, and my dear students. On behalf of management, staff, and student of YIP Institute of Pharmacy, I express warm welcome and gratitude for being present today. We are honored by your gracious presence at national level webinar series on trends in pharmaceutical sciences and research, organized by IQC, IIC Cell and Research Cell of YIP Institute of Pharmacy, Aurangabad. In the journey of fulfilling our vision of education for mankind, YIP Institute of Pharmacy, Aurangabad was established in year 2004. This is a generous gift to the society by our honorable chairman, Sri Yashwantrao Gadak Patil sir, under the able guidance and leadership of Sri Shankarrao Gadak Patil sir, Cabinet Minister of Soil and Water Conservation, Vice Chairman Sri Udayandada Gadak Patil sir. The institute has reached commendable heights in the field of pharmaceutical education and research. The IQC cell of this institute was established in the year 2017 and entrusted with the role of upholding and enhancing quality initiative of the institute. The institution's Innovations Council was established in year 2022 under the Ministry of Education, Government of India, systematically foster the culture of innovation at higher educational institute. The primary mandate of IIC is to encourage, inspire, and nurture young students by supporting them to work with new ideas and transform them into prototype during their informative years. The research cell was formed under the promotion committee was established in year 2017 to promote research, publication, and innovation among students and faculty. The research cell under the guidance of IQC has been instrumental in conducting various programs and initiatives such as faculty research commitments, research benchmarking, and mandatory plagiarism check for students and faculty. The research cell of YIP Institute of Pharmacy has also coordinated with College Development Committee for upgrading of research. The objective of today's program is to expose students, teachers, researchers, and industry experts to the new avenues and research areas in the field of pharmaceutical science. The program is envisaged to increase the awareness about cross-functional innovations and updation to the scientific community. The program outcome such as lifelong learning, pharmacist and society modern tool uses, and professional identity are closely related to the objective of webinar series. This program has been possible because of generous support, blessing from management, and untrying hard work by teaching and support staff of this institute. Esteemed speakers of the webinar series are stalwarts and internationally acclaimed experts from their respective field. I once again welcome all of you for this wonderful event, and I am sure that this webinar series shall inform, educate, and inspire all of us to achieve new heights in the field of pharmaceutical innovation and research. Thank you.
Thank you, sir. Now I request our principal, Dr. Sachidanand Angadi sir, to deliver welcome address. Over to you, sir.
Good morning, all participants, dignitaries. At the outset, I wish you all a very happy good morning. First of all, let me extend my sincere and warm greetings to all the dignitaries, eminent speakers who have consented to be part of this webinar series in a very short period of time. And it is only because of their perfection, the achievements that have been possible within this short period of time. They have found their time available and they have committed themselves for the interest of the budding pharmacists, young researchers, and faculty members. Trends in pharmaceutical sciences and research. This is a relatively generalized topic which involves the trends that are undertaking in the professional by the various sectors, like in the academicians, newer developments by the academicians, the newer areas of research by the academicians, by the industry people, different trends that are undertaken in the different departments of the pharmaceutical organizations. In order to make this known to all of the participants, this national level webinar series has been organized. At the outset, I would like to extend my sincere thanks to the management for permitting us to conduct this national level webinar series. Our beloved Joint Secretary, Sir, Dr. Vinayak Deshmukh, Sir, who is ever a green supporter for our institute and for such initiatives. All of the dignitaries, participants, I extend you the warm wishes. And just to give you an idea, within a very short notice of the time, this flyer was made viral, and we have almost 1,500 participants who are registered for this particular webinar series. And the participants, this belong to different states across India. Participants are from Maharashtra, Telangana, Andhra Pradesh, Odisha, Kerala, Karnataka, Uttar Pradesh, Assam, Uttarakhand, West Bengal, Tamil Nadu, Madhya Pradesh, Delhi, Gujarat, Haryana,
माझा क्लास
Punjab,
चालू आहे, मी थांब मीटिंग चालू आहे.
Himachal Pradesh. It is very heartening to see the participants from across different states of India, and I feel and I am sure the purpose of arranging this webinar series will definitely be served, and I am sure all the dignitaries and speakers will definitely give justice to all of the participants. Thank you, madam.
Thank you, sir. Now I would like to request Dr. Vinayak Deshmukh, sir, Joint Secretary, Mula Education Society, Sone, to guide us. Over to you, Deshmukh, sir.
Good morning to all of you. I said Dr. Deshmukh, Joint Secretary of Age Group of Institutions, Sonai. On the above management, I welcome all the delegates and the most important, all the resource persons, those are going to contribute for this webinar, national level webinar, that is Trends in Pharmaceutical Sciences and Research. Yash Group of Institute is working in Ahmednagar, Pune and Aurangabad district of Maharashtra, having a wide range of professional colleges, which includes dental college, pharmacy colleges, agriculture college, science colleges, and state board, CBSE and Marathi medium schools. On the above this particular webinar, I congratulate Dr. Angdi sir and his team members for arranging the national level webinar, and they have selected a topic which is having a wide range, and the various renowned persons are selected, and they are going to deliver lectures on the topic. At the same time, as per the Dr. Angdi sir, a very good response is there from all over India to this particular national level webinar. And it is possible just because of online mode, and which has opened the wide angle, I can say, in which various research person, academician, they can join this particular activity without wasting much time. If it was offline, I don't think so. Academician just webinar. So I can say that this is the opportunity which is given by COVID pandemic to us, and post pandemic also we are going to use this particular online mode, which really creates the wide communication in between various pharmaceutical academician as well as the research person. I hope that all the resource person, they are going to deliver their lectures, and they will be focusing on recent trends and in delegates with their lectures. So once again, are thankful to all the delegates as well as all resource person, those are going to contribute in this particular activity. Thanks a lot. Thank you.
Thank you so much, sir, for boosting our morale. Now, I would like to call. I request Ms. Renuka Sonone to propose vote of thanks. Over to you, Renuka.
Yes, ma'am. A very good morning to honorable dignitaries, Dr. Pramod Khedkar sir, HOD, Department of Pharmaceutical Science, Rashtrasan Tukdoji Maharaj, Nagpur University, Nagpur, Dr. B. Geeta ma'am, Professor and HOD, Department of Pharmaceutical Analysis, Sri Abhirami College of Pharmacy, Coimbatore, and Dr. Jaiprakash Sangashetty sir, Associate Professor, YB Chavan College of Pharmacy, Aurangabad. Distinguished guest Dr. Vinayak Deshmukh Sir, Joint Secretary, Mula Education Society. Respected Principal Dr. Sachidanand Angadi Sir, Yash Institute of Pharmacy, Aurangabad, and dear delegates. On behalf of Yash Institute of Pharmacy, its entire fraternity, and the organizing committee, I would like to express my gratitude to all the esteemed delegates of the webinar for their gracious presence at the inaugural function. I extend my gratitude to our esteemed speakers to take out time from their busy schedule to grace the inaugural function. I would further extend a hearty thanks to Dr. Vinayak Deshmukh Sir, Joint Secretary, Mura Education Society, Sonai, for being with us today and inspiring and encouraging us with your words. A special thanks to our beloved Principal, Dr. Sachidanand Angadi Sir, Yash Institute of Pharmacy, Aurangabad, for addressing webinar with welcome note. I mention my deepest sense of appreciation to all the delegates because of whom we made this function possible. Events like this cannot happen overnight, so as the wheel starts rolling weeks ago and requires planning and bird eye for details. Here we are fortunate enough to be backed by a very dedicated and motivated team of our Yash Institute of Pharmacy. I once again want to state that we are grateful to all the speakers and participants. Thank you for being with us. It has been a great pleasure. Have a wonderful day ahead. Thank you.
Thank you, Renuka. Now let's start our first session. Dear, may I now request Ms. Sana ma'am to introduce our first speaker of the day, Dr. Pramod Khedekar sir, HOD, Department of Pharmaceutical Science, Rashtra Sant Tukoji Maharaj, Nagpur University, Nagpur. Over to you, Sana ma'am.
Thank you, Tara ma'am. Respected chairperson, respected principal, honorable resource persons, faculty members, students, and all the members who have joined us today. A very good morning to all. I feel proud to introduce Dr. Pramod Bhujangrao Khedekar sir, who is presently working as the professor and head in the Department of Pharmaceutical Sciences, Ratrasan Tukadoji Maharaj, Nagpur University. Sir has 33 years of professional experience. In 1987, Pramod sir has completed his B.Pharm with first class. He is a gold medalist in M.Pharm from the Department of Pharmaceutical Sciences from Nagpur University. Sir has also completed his DBM in 1989 with first class under Nagpur University and qualified MSCIT in 2004 with first class. Sir has completed his PhD in 2005 from Nagpur University, and today Sir is working as an approved PhD guide for Nagpur and Amravati students. Under his guidance, 9 students has completed their PhD and more than 45 students has completed their M.Pharmacy. The icing on the cake goes on to the international research collaboration done by him. Sir has 4 patents, 1 published and 3 granted to his credit. He has also published 44 research papers in international journals and 17 research papers in national journals. He has presented research work in more than 90 conferences and added more fur to his cap. He is the author of 1 book. I feel proud to announce that Sir has delivered more than 25 guest lectures as a resource person. He has successfully completed 1 UGC major research project and 1 URPS. He attended 25 staff development programs and 35 conferences, seminars, and workshops. Last but not the least, he won 11 medals and awards like APTI Best Teacher Award, Commonwealth Academic Fellowship of Royal Society London, UK, and Best Scientist Award in the year 2005. We welcome you, Sir, in our midst and hope you will have an enjoyable time with us. Over to you, Kalaman.
Thank you, Sana ma'am. Now I request Dr. Pramod Khedekar sir to address our participant on topic Stereochemical Trends in Pharmaceutical Science and Research. Over to you, sir.
Are you able to hear me? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Very good morning to all. And thank you to Sana Sheikh, Kale Madam. Thanks to the organizer for inviting me as a guest speaker in the national level webinar series on trends in pharmaceutical sciences and research. Thanks to the principal, Dr. Angadi sir, then Joint Secretary Dr. Deshmukh sir, who has given me the chance to have interaction with you. And my topic of today's webinar is stereochemical trends in pharmaceutical science and research. And I thank to the research cell, IQAC, and Institution Innovation Council, IIC, which has been established by the college. And I welcome you all in this today's national level webinar series. Now, stereochemistry is actually a part of our life. And usually I say, without chemistry, life is not possible. And to that chemistry word, if you prefix a stereo word, it becomes stereochemistry. So stereo indicating that it is an going in three-dimensional way, solid. So when we study the things, material or the chemicals in a three-dimensional view, so that will be the part of your stereochemistry. And as such, stereochemistry is used in development of our this pharmaceuticals, biologically active compounds, agrochemicals. Without that stereochemistry, you can't synthesize or design any molecule which are available in market as a medicine. Stereochemistry also involves in the process of asymmetric mechanochemistry. Symmetry is there and asymmetry is there. So it involves in asymmetric mechanochemistry. This also involves in kinetic separation reactions. So where you'll be able to separate the reactions based on pharmacodynamics and pharmacokinetics. It is also involved in the process of sequential enzyme binding model, where enzymes are required. Our body is full of enzymes, and that enzymes has to be sequenced and that has to be binded. So it will also involve the stereochemistry will also involve in the sequential enzyme binding model. Now, one slide I am showing how that stereochemical trends plays a vital role in your pharmaceutical sciences and research. Now, this slide is actually highlighting the stereo regulation in calcium methacrylate that is driven by formation of a chelating bridging scaffolds. Scaffold means a cluster or structures that electrostatically activate and control the polymerization at the same time. So it involves stereochemistry. Without that, you can't design the calcium entrapment in the drug molecule. And these scaffolds, they are actually destroyed by polar solvents and or if non-chelating counter ions and use instead. So the calcium supplements or the drugs we take, they have the stereochemical this basis. Now another this application here in that case of this stereochemistry, if any structure that is having flexible side chains or rigid side chains. Now, actually, if flexible side chain will be having an handedness affect biological and this rigid side chain that have the handedness and does not affect the biological properties. That means whatever biological the drug molecule is having, it will exert. So that rigidness of the structure is required. So based on that, you can have that criteria. A reference I have quoted here. The another example here in that case for the structure stereospecificity relationship of propylene polymerization. In polymerization also, here the examples are of that symmetric methiphenylsilane bridge, fluorinyl naphthyl amido titanium complex. The first complex is there, and the second complex is of diphenylsilane bridge, fluorinyl naphthyl amido titanium complex. So where in presence of this dried modified methyl aluminum oxane, it will get converted into an stereochemical way and you will have the this biological action. Now this diphenylsilane bridge complex 2 that exhibit much lower activity than that of the methyl phenylsilane bridge complex 1, and also indicating that sterically this bulker phenyl substituents that prevents the rotation of naphthyl amido ligand and resulting in steric hindrance on the metal center. Now just this I am briefing out. Based on this, we'll come to the basics. Now here, after having that stereochemical trends or taking into consideration stereochemistry, the outcome will be your enantiomers that will have different effects on the human body. The example you can have of propoxyphene, methorphan, they are having this analgesic antipyretic activity. One enantiomer that is more effective than the other, that is of the ibuprofen, then one another enantiomer that is useful while the other causes harm, thalidomide and ethambutol. We are aware of thalidomide and ethambutol. Here in that case, the two enantiomers like of dextro propoxyphene and levopropoxyphene have a specific this to different receptors and hence elicit different responses in the human body. Similarly, your ethambutol, if the stereochemical structure SS and rotating this plane polarized in positive direction, that is used for treatment of tuberculosis, and whereas its counterpart having that rectus or the negative sign ethambutol that causes blindness. Same is the case with thalidomide, and n number of examples you can quote. So just I am briefing out why that stereochemistry plays a vital role in designing drug molecule. Nowadays, this last 2 years, we are suffering from that virus, COVID virus. Now, for that purpose, also stereochemistry plays a vital role in drug repurposing or is a tangible strategy for developing antiviral agents within a short period. So, this is also possible for developing the antiviral drugs within a short period due to stereochemistry only. And it starts with the virtual screening of the approved drug employing docking simulation. Now, one slide I have shown. So, based on that, you can have the anti-COVID drug or you can design it. So, which will be illustrating in that case. So, stereochemistry plays there also a vital role. So, here in that case, the shape similarity you can have, docking you can have, interaction similarity you can have, and structure-based virtual screening after docking, and then you can design the molecule, knowing the drug target interaction and knowing the disease. Here in that case, the novel drug target interaction to the COVID-19 or the SARS, COVID-2 drug targeted, they were designed by taking into account the stereochemistry. So this drug repurposing approaches, the time for drug development can be reduced in emergency, and repurposed drugs have already been found to be safe. So it plays a vital role. Now, what are the basis for this? So with some basics, we'll correlate the things and we'll have some drug molecules. I hope you are able to hear me clearly. Kaya madam?
Yes, sir. You are audible, sir.
So that in between I will have some response from your side. Otherwise, it should not be one way.
Yes, sir.
So I will continue. Now the basic this carbon atom that is involved everywhere, drug molecule. So here in that case, one this tetrahedral carbon I want to show. I am having that stick ball model with me. So if you are visualize, are you able to
Sir, voice is not visible.
see? Now this stick ball model you are able to see.
Yes, sir.
So I am holding this carbon atom or a methane molecule, CH4. So how it looks in stereochemical way, in three-dimensional way. I am just rotating it, you can see it. So here the white balls, they are hydrogens and the black is carbon. And here tetrahedral carbon atom, in the slide I have included, and this tetrahedral carbon atom, how it is there, angle and other things. Based on this carbon atom, tetrahedral carbon atom, all drug designing or all stereochemical trends in pharmaceutical sciences and research are based. So that is the basic of this. So again, I will share my screen. I hope you are getting it. So response from your side should be there.
Yes, sir.
Now here the tetrahedral carbon atom that is used in your stereochemical trends in designing the drug molecule in pharmaceutical sciences and research. Now here in that case, you can see this, the carbon atom I have shown and two solid lines I have shown. So that two solid lines, they are in one plane, and the dark line that is coming toward the viewer. So it is tapering toward the carbon atom and coming away, and the dotted line that is on the rarer side, and the bond angle is 109.5 degree, perfect angle. Now, this carbon atom, the tetrahedral carbon atom, regulates each and everything in drug designing, or it regulates the stereochemistry, and you can have n number of drug molecules, and you can synthesize, you can take into account. So, this tetrahedral carbon atom has to be taken into account while designing all molecules. So, and it contributes toward the stereochemistry. Now, I hope you might be aware of this. Just I have included this slide. Stereos means solid, and that is the science of organic chemistry that is dealing with structure in three-dimensional. And based on the relationship between molecular structure and properties, here in that case, the study of static and dynamic aspect of the three-dimensional shape of molecules will be provided foundation for understanding structure and mechanism in organic chemistry. So without that, you can't go further to have the drug designing or having the this research in synthetic chemistry. Now, this most of the student, they might be aware of this, or the participant today that they have gathered. Now that organic compounds, they are actually hydrocarbons. Why they are hydrocarbons? Hydrogen and carbon element are there, and then the further division is there: aliphatic, aromatic. Then here in that case, aliphatic, you can divide alkane, alkenes, alkynes. Then cyclic aliphatic, that is very important, cyclohexane. Now this cyclohexane regulating the all stereochemistry. If you try to prepare a stick ball model of cyclohexane, it will be converted into a chair form, stable form. You can interconvert to boat form. So as we know, chair, we sit on chair, that is stable. That means the cyclohexane chair molecule will be stable. Boat, if you have experience of boat, if you ride in boat, it is highly unstable. So same is applicable for the non-living things or to the organic molecules, which is applicable to living things. So here you can correlate the things, living things and non-living things. Organic molecules, they are non-living, but though they are non-living, but they behave like an your this living things. So you can correlate this. Now this cyclic aliphatic compound, that is the head coming under the hydrocarbons, it is very important in drug designing. If you understand the stereochemistry of cyclohexane, all stereochemistry of drug designing will be simplified there. And the another category, if it saturate that cyclohexane, you will get an benzene molecule. Now here in that case, benzene, I will show the stick ball model. Here in that case, how it is there, and you can have the comparison. Now if you try to prepare a benzene molecule, here in that case, now this benzene molecule having this double bond, 3 double bond, and if you try to prepare a model, it will go flat. So this is a flat structure, it doesn't have 3-dimensional, it goes in 2-dimensional. And if you try to convert this into an fully saturated compound, that is cyclohexane, it will have a dimensions. It will get converted into chair form. So clear-cut differentiation is there. And you can have the aspect of drug designing. So how that benzene is there and how cyclohexane is there. Again, I will share my screen. So just in comparison, you can have it, and based on that, you can have the stereochemistry or the stereochemical trends in designing drug molecules. There are various forms of representing organic compounds. Here, the non-cyclic compound, they are represented in different way, and cyclic compound, they are represented in different way. So like ethane molecule having empirical formula, molecular formula, and structural formula. And structural formula. Now, these are the basics that helps in drug designing. Now, here in that case, the chain formula, Fisher formula, Andrew formula, the stick ball model that I have using, then the Newman projection, then electronic formula, and the ball and stick formula. Now, all this contributes toward the drug designing. Without that, you can't design a drug molecule. Now, the cyclic compounds, already I have mentioned about cyclohexane. Same way you can represent cyclohexane, empirical molecular structural formula, and then the chain formula, polygon formula, or the Howard projection, then the wedge and dash drawing, and then ball and stick model, Newman projection, and then comes the chair formula. So we are interested in that chair formula. Here in that case, the chair formula. Here in that case, the chair formula regulate the thing. Now, behind this, while designing this stereochemistry, it has a history. Long back, it begins in 1815. Jean Baptiste Biot, the organic stereochemistry was started by him, and he found certain organic compounds or molecules that rotate the plane of polarized light in solution or gas. And this activity is called as optical activity. The polarimeter experiment, you are aware, that was designed by Jean Baptiste Biot. And then in 1848, Louis Pasteur described the optical activity, or due to the presence of some dissymmetric grouping of atoms in molecules, and experiments made on tartaric acid, and he confirmed that asymmetric grouping or the chiral carbon atom is required for optical activity. So that was designed by Louis Pasteur in 1848. He was also a microbiologist here in that case. Then our chemist Jacob H. Ventoff and J. A. Lebel, they laid the foundation of stereochemistry and postulated asymmetric carbon model tetrahedral arrangement. So that tetrahedral arrangement, the very first slide that I have shown. So here in that case, that concept was given by this Jacob H. Ventoff, and the concept of three-dimensional structure that was awarded with chemistry Nobel Prize, and it was the first recipient of the prize. So at that, in long back in history also, long back before 100 years ago, they were not knowing anything, but still they were realizing the presence of this, and the scientist has got the first Nobel Prize in chemistry. So that is the contribution, and from then onwards, the things start to begin development stage. So this shape and size of tetrahedral carbon atom in methane, that is regulating here, already I have shown it how it is there. And from that, evidence of the isomer number, the Greek isos means identical and meros part. So that identical part, only the tetrahedral structure for methane agrees with the evidence of isomer number. Without that, it will not proceed. And this isomer number here in that case will be regulating each and everything in our drug designing or in the stereochemical trends in your research or in pharmaceutical sciences. Now here in that case, already I have mentioned about the tetrahedral carbon shape and size. Here in that case, again, that slide is there. And you can see it in that here, the bond length, how small it is, 1.10 Armstrong. So that is equivalent to 1 into 10 raised to minus 12 centimeters, and that is equal to 1 Armstrong. So here in that case, you can have the clarity. Now coming to the concept of chiral carbon atom. So this chiral carbon atom, that Greek word cheer, hand, a chiral object that is not superimposable on its mirror image, and any object that cannot be superimposed on its mirror image is said to be chiral, and that is possesses the property of handedness. Now our left hand is the mirror image. Mirror image, here in that case you can see it. Just I will show it how it is there. Now suppose his two hands are there, correct? Now actually they are mirror image, you can see it, and to have a superimposition you have to turn this, so then and then only it will be superimposable. So you can see it, handedness. In now we have to rotate my hand with 180-degree plane. So here in that case, and here if you find it this, there, here in that case, non-superimposable. To superimpose, you have to change this. So the same thing applies to the organic molecules. Simple way, handedness. So I hope you are getting it, what I am telling. Now here in that case, the same thing, handedness. Our left hand is the mirror image of our right hand, but the two hands are not superimposable. That I have shown with my hand. Again, another examples also you can put. Hand gloves are there, shoes are there. Now coming to the organic molecules, how that chirality or asymmetry is regulated. Now that chirality or asymmetry, in the very first slide, I have mentioned about that asymmetry in stereochemical applications. So that is here, the basis lies here. Now here this chirality or handedness or phenomena shown by a chiral carbon atom. So that has been marked by asterisk. And the example of lactic acid. Lactic acid is present in milk, and almost everybody take milk in either form, either in tea or in other preparations, milk preparation, dahi is there, or the items that are prepared from milk. So that contains lactic acid, and there also the stereochemistry is there. So every day we consume stereochemical molecules, and you can have the correlation, and body accept that stereochemical molecules, and based on that we get the activity. So here in that case, the lactic acid, the very basic molecule is there, which is a stereochemical molecule, which is having the chiral carbon atom, or which is having the chirality or asymmetry. Now this lactic acid that are not superimposable on their mirror image, they are chiral. A carbon atom to which 4 different groups are attached, that is called as the chiral center or the chiral carbon atom. I hope you are getting it. Now here the stick ball model, how it looks, lactic acid, where that red ball that is indicating oxygen, white balls that are your hydrogen, and black balls they are carbon atoms. Now here from that itself, the isomer number, the word isomers came into existence. The Greek word isos means identical and meros means part. And isomer, they are different compounds that have the same molecular formula. And isomers, they are non-identical molecules with the same atomic composition. Now in drug designing also, isomers plays a vital role. Without that, you can't design a drug. Now, based on that isomers, they are having, like our constitution is there, constitutional isomers are there. The stereoisomers, just you prefix the word stereo to isomers, it will be stereoisomers. And based on that
Screen is not visible.
isomers,
Sir. Sir. Hello.
1 minute.
May I audible, sir?
Screen is visible now? Screen is visible or not?
Direct all India combined practically म्हणलं
Other should mute. Other, they should mute themselves. Hello.
Request all the participants.
Hello.
I request all the participants mute yourself.
Participants should mute themselves, and the screen is visible now.
Yes, sir. Visible. Visible, sir.
Continue. Now, as our Indian constitution is there, the same constitution is also applicable in your stereochemistry or the drug molecules. And based on that, just will prefix the word constitutional isomers. And the constitutional isomer, they are actually structural, positional, and different functional group isomers. You can have the examples of butane, methyl propane. Then here in that case, the normal butane, the same molecular formula, it can be represented in different structure. So that different structure, it will have a different compound. Now position, if you change the position, the name changes. Like here 2-bromo 2-levene, aromatic compound. If you change the position, it becomes 3-bromo 2-levene. Molecular formula same, C7H7Br. Then you can have the different functional isomers also, like benzoic acid. Here in that case, benzoic acid, here in that case, the molecular formula for benzoic acid is C7H6O2. Now this, you can change the functional group in different way, and you can get the other molecule, that is orthohydroxybenzaldehyde. So it actually describes the constitution of the isomers or the organic compounds, like our constitution. Now, just if you add the word here isomers, here you end with ism. So you are fixing that ending, suffix, prefix, begin. If I so isomer can be converted into isolate, forming the nouns, an action or its results, and the phenomenon of a single molecule can be represented more than one, will be called as isomerism. So here isomers of the parent compound glyceraldehyde. Now why glyceraldehyde is called as a parent compound? From this, all your carbohydrates, they are actually originated. Kilani-Fischer synthesis starts from this basic molecule, that is glyceraldehyde. So that glyceraldehyde, if the hydroxy group on chiral carbon atom is on right side, that becomes D-glyceraldehyde. If it is on left side, it becomes L-glyceraldehyde. So it is having the significance here in that case. The stick ball models of that isomerism of your glyceraldehyde, how it looks. Then these stereoisomers, they are studied with three-dimensional aspects, and that will be called as stereoisomers. And the phenomena, if you represent that isomerism, the phenomena whereby a single molecular formula can represent more than one compound in three dimensions will be called as stereoisomerism. So this requires while drug designing, and this stereoisomerism occurs in molecules with identical structure, by which is meant they have the same order of atom but differ their this spatial arrangement, space arrangement, or the configuration. From here itself, configuration, probability, that word came into existence. So while designing also, this configuration plays a vital role. Probability. What is the probability? While having that pharmacological activity in relation with the chiral atom. Now here in that case, at this particular point, you can classify that stereoisomers in a different way, either configurational or conformational. So we will be more interested in conformational. And these configurational isomers, they are enantiomers, diastereomers, geometric isomers, relative isomers, absolute configuration. And then further, this enantiomers, they are the mirror image, non-superimposable, and your optical isomers comes into existence, where it is represented by dextro, small d, or positive sign, levo, this small l, italic, negative, rotating the plane polarized in anti-clockwise direction, and the mixture, racemic, positive, negative, dl. Then the diastereomers, dia means two. Slides are not visible.
No, sir. Now only.
They are visible?
No, sir.
No, sir.
Yes, it is visible, sir.
Okay, we'll continue. Sorry for the disturbances. We are having some this internet issue.
No problem.
So we'll continue. Now dia means two, and they are not mirror images. And from dia itself, we get the mesostructure. Geometric. Now we study geometry in your school education. So same geometric isomers are applicable here also. Like cis functional groups are same side trans, then ZNE, then the relative isomers, they are in relation with your sugar molecules, erythro-3O, then the capital D and L. So actually this D is the starting parent compound, D-glyceraldehyde, from where it has been originated, and the L, the bulky group, comes on left hand side. So it doesn't have that correlation with your dextro and levo. It is a series, D and L series. And nowadays the concept of absolute configuration is there, like absolute alcohol, that means extra pure, 99.9% pure. So here that absolute configuration is applicable in same manner, and we can design that molecule as whether R and S, rectus and sinister, in that manner only. Now coming to the configuration part. Configuration, that is the manner of arrangement, shape or outline, arrangement of atoms that characterize a particular stereoisomer, will be called as configuration or the probability. Now just now I have uttered that word probability, and it is in correlation with the pharmacological activity of the molecule, what probable activity it will be giving. So you can correlate the things and you can design that molecule. Now based on that this configurational stereoisomers came into existence. Now configurational stereoisomers, they are the manner of arrangement, shape, outline, attachment of the atoms in three dimensional. They will be called as your configurational stereoisomers. and configurational stereoisomers, they are interconverted by inversion or turning inside out at the chiral center, and we can get the different molecules with the same molecular formula, and you can have a different activity, whether that activity might be your non-toxic activity or toxic activity. In the first 1 or 2 slides, I have mentioned that. Now, enantiomers. Enantio, the Greek word meaning opposite. Isomers that are mirror image of each other, they will be called as enantiomers. And two stereoisomers that are not superimposable mirror image of each other. And the example here in that case, here at that particular point, the example that I have quoted of 2,3-dichloropentane. So that comes under the category of your enantiomers. The stick ball model, how it looks. So here in that case, here the chlorine moiety that is represented by the green ball. The cyclic model also of that, you can have it 1,2-dichlorocyclopentane, how it looks. And the enantiomer have an identical chemical properties except toward the optical active reagents. And they have identical physical properties except for the chiral direction of rotation of the plane polarized light. Now the phenomena for the enantiomers that will be called as the phenomena of formation of enantiomers will be called as enantiomerism. That much simple it is. Like isomers, isomerism, enantiomers, enantiomerism. Now based on that optical isomers, now optical isomer, they come from the optical visuality or according to optics. Optics that is related with our eye or optic of eye or sight. And some substances, they are rotating the plane polarized light. Such substances, they are called as optically active. Rotating the plane polarized light, right, either in right direction or anti-clockwise direction or clockwise direction. So based on that rotation of plane, is the right clockwise, the substance is dextro-rotatory, dextra, that means right, and denoted by italic D in bracket or a positive sign. And if the rotation of plane is to be left, that is counterclockwise, the substance is levorotatory, Latin, levus, left, and that is denoted by that italic L in bracket or negative sign. Now, all these things, they are actually required while designing molecules. When we do research in our laboratories, without that, we can't design any drug molecule. So they actually play a vital role in designing the drug molecule. And based on that, your optical isomers came into existence. The lactic acid, already I have taken the example here in that case. The optical isomers, glyceraldehyde, you can name that glyceraldehyde. Here D, it is actually denoting that rotating plane polarized light in right direction, L in anti-clockwise direction. Now the modification, racemic modification, it also plays a vital role while separating the molecules, stereochemical molecules. A mixture of enantiomer that is called as racemic modification, and which is optically inactive if the mixture is 50-50. And when enantiomer, they are mixed together, the rotation caused by a molecule of one isomer is exactly cancelled by an equal and opposite rotation. Here in that case, if any problem is there, you can raise your hand or you can ask. Slides are visible, na?
Visible, sir.
Oh, okay, I continue. Now, based on this itself, the another phenomena, diastereomers came into existence. Dia means two. For more than one chiral centers, stereoisomers that are not mirror image of each other, they are called as diastereomers. And diastereomers are stereoisomers, but not enantiomers. So here in that case, at this particular point, this diastereomer, the example which are not mirror image, that is 2,3-dichloropentane. I have shown the structure, and the asterisk indicates that chiral carbon atom. So at that particular point, you can have that correlation with this. Now the diastereomers, they have different physical properties, chemical properties, which are not identical and may be optically inactive. So here in that case, not necessary that it is optically active. The phenomena of formation of diastereomers will be called as diastereoisomerism. So that much simple it is. And that phenomena will be regulating the pharmacological activity. Now the mesostructure. Molecules, they have symmetric end. The term meso is used. Meso means combining from the middle or intermediate. And a meso compound is one whose molecules are superimposable on their mirror image, even though they contain chiral centers. And a meso compound is optically inactive. The example is 2,3-dichlorobutane that is superimposable if turn end for end a meso compound in the same plane. Now this meso structure, I have shown that line for 2,3-dichlorobutane. And in the mesostructure, one half of the molecule is the mirror image of the other molecule if you fold it. And in meso compounds, two chiral centers have opposite configuration. Now, based on this itself, the geometry came into existence for the molecules, or from stereochemical way for the isomers. Now, this geometric isomers, it is actually a science of properties and relations of lines and bonds. Geometry means lines and bond. So same is applicable for our organic molecule, and they doesn't require chiral carbon atom. And the particular kind of diastereomers that owe their existence to hindered rotation about double bond, that will be called as your geometric isomers. Now these geometric isomers, they are actually the configuration of the isomeric two butenes. You can have this cis and trans. Now here cis meaning Latin on this side or same side or identical, and trans Latin meaning is across or opposite. You can see here in that case in the first structure why it is cis, that is 2 butene. The methyl group, they are on the same side of the double bond. Whereas in the same structure, if you have the methyl groups on an opposite side, so that is opposite side or across, that will be called as trans. Trans axial, trans diaxial, then cis axial, cis equatorial. They plays a vital role in designing the drug molecule, cyclohexane molecule. We'll come to that also. Now here how that geometric isomers in stick ball model looks. So there you can have that idea, cis and trans. Then the phenomena here in that case, geometric isomerism. The phenomena forming geometric isomers is called as geometric isomerism. And a pair of geometric isomers, they are then diastereomers as they are not mirror image. And geometric isomers, they are interconverted in principle by rotation about a double bond. And geometric isomers have different physical and frequently different chemical reactivities. So you can have that idea while designing the drug molecules, and you can correlate their physical properties, chemical properties, and pharmacological properties. So that is the basis of that geometric isomerism. And here geometric isomers for cyclic compounds, how it will be denoted or how it will look. Now the cis decalin. Now that decalin, actually it is having two cyclohexane ring. Now two cyclohexane ring, they are actually more stable in your chair form. So that I have shown in the other structure cis decalin, where the fusion shows that the hydrogens, they are on same side. So that's why it is called as cis. So cis word in cyclic compound, that is in correlation with the fusion of the two rings. So here two rings they are fusing and hydrogen coming on one side. Now same the trans decalin, how it looks. Now in the flat structure I have shown the dotted line hydrogen below plane of the ring. So that can be more clearly depicted in that cyclic structure chair form, and the two hydrogens, the one is coming above plane of the ring on the fusion side and other is going below plane of the ring. But they are trans, and they are actually trans diaxial, axial perpendicular. So clear cut you can have that idea with the slide, and you can have this thing while designing drug molecules. Or in steroids, it plays a vital role. Steroids, they are very good medicines if they are used in proper dose, and their steroids pharmacology or the activity is regulated by this stereochemistry. So while designing that molecules, steroids as such, they are affecting your immune system, but if they are used in excess or used for long duration of time, otherwise steroids they are safe. In this treatment also, dexamethasone was used. The reason is that here, and in most of the diseases also, if some diseases they are not cured by your traditional medicines or the normal medicines or antibiotics, the doctor gives one drug, that is steroid, for a particular time of duration with a particular dose, and you can have a control on that disease. So that is the significance, and where actually in drug designing it is controlled by stereochemistry. I hope you are getting it. Now the geometric isomers or the cyclic compounds, how they look in that stick ball model, that here also I have shown you. Just a minute, I will have a glass of water. How that trans decalin molecule looks here, that you can have it. You can have the comparison here. Now here in cis, it is causing the crowding, whereas in trans, all groups they are separated, so no interaction or no steric hindrance. And such type of molecules, the transfusion molecules, they can very well cross the blood brain barriers and they can exert their activity at the target. Whereas this cis molecule, it will not cross the blood-brain barrier and it will not reach to the target and it will not exert its activity. So this fusion plays a vital role while designing the drug molecules. In the market, based on this itself, the molecules came into existence. So that is the theme behind cis and trans. Notation Z and E for the geometric isomers. Z German, Sussman, that means together. E again antigen, opposite side. Examples that are quoted. So nowadays Z and E is also used for nomenclature purpose. For the example 1-bromo, 1-chloropropene. So here in that case, and the priority is taken into account. Methyl group is preferred over hydrogen, bromine is preferred over chlorine, and based on that, the name is given or the configuration is given Z and E. The stick ball model, how it looks on the priority basis and how it will be having its effect. Now coming to the relative configuration, relative configuration. Now it plays a vital role in designing your sugar molecules. Erythrose sugar, threose sugar, that actually comes from this erythro and threo, used for molecules having non-symmetrical ends. Glucose molecule is having non-symmetrical end, and in Kilani-Fischer synthesis, in the second step, this erythrose and threose came into existence. From that itself, generally used in the Fischer projection, and they are not mirror images, and they resembles with the diastereomers. So you can have that structure of erythrose having 4 carbon atom and the threose. So here 2 like functional groups. They are actually the products of Kilani-Fischer synthesis, where this erythrose and threose came into existence in the first step of KFS, Kilani-Fischer synthesis. Now erythro meaning same site. Now what same site? The hydroxy groups that are attached to the chiral carbon atom, they are on same side. That becomes your erythro structure, and the molecule, sugar molecule at the C4 level or the tetrose level, that is called as erythrose. And its counterpart, if that hydroxy group, they goes on opposite side at the chiral carbon atom, second and third, they will be called as threose. Threo word has been prefixed. So here also, now glucose molecule, we are knowing it is a very important molecule. Without glucose, our life will not be possible. The energy that we required to interact or to perform our day-to-day activities or the basal metabolic rate requires energy. So that energy comes from glucose, and that glucose is actually synthesized from Kilani-Fischer synthesis. So in the next step, a pentose sugar, and then comes your exose sugar. So it is having the relevance with stereochemistry. The stick ball models, how it looks,
Excuse me,
that
sir.
you can have that idea. Yes.
Dr. Khedekar, sir. Screen is not visible, sir. Can you please
Yes.
share?
Okay, 1 minute. And now it is visible, madam?
Yes, sir.
Okay. Sorry for that interruption.
No, it's
And from your side, madam, someone is sharing the slides, so that's why it is happening. Any participant or somebody is doing the thing, and based on that, the interruption is occurring.
okay.
Otherwise, from our side,
I'll search
everything
for
is
that,
okay.
sir.
Just you check it. Oh, okay, check it, madam. No problem. All participants, they are requested to listen quietly, and then we'll have a question answer session at the end. And if any problem is there, you can just raise the hand or you can have the things. So I can continue.
Sir, yes.
Okay, thank you. Now the stick ball model of that threose and erythrose, how it looks. So that I'm showing here in that case. And based on that, you can have the drug designing of the sugar molecule. Now the relative configuration D and L. Now this capital D and capital L, you don't get confused with that small d and small l, that is with dextro and levo. It is clear-cut differentiation used for the molecules having non-symmetric ends. Generally in glucose molecules, it is used. And orientation of that hydrogen bond and hydroxy group on chiral carbon, which is farthermost from the primary chiral carbon atom, and generally used in Fischer projection. So this, now here it will be more clear. I have highlighted with that D. Farthermost chiral carbon atom in your glucose molecule is the 5th carbon atom, and that is having the bulky group on right side. So that's why it is D series. And if I rotate it, that hydroxy groups comes on left side, that becomes your L series. So D glucose and L glucose in Fischer notation, very clear. And you can correlate this with cyclic structure, and that you can correlate with your cyclohexane or that chair structure. Now coming to the absolute configuration R and S, that was suggested by Ken Ingold Prelock. So they are calling it as CIP system. And here this R Latin rectus meaning right, and this S Latin sinister left. Actually, at that time they were not knowing. The scientist Ken, he was having his initials as R and S, and he has denoted that this configuration, absolute configuration, by RNS to have his identity. And coincidence, it was there that R Latin, it correlate with the right rectus, and that S Latin sinister, that correlate with that left. So how correlation is there? And the scientist, he was belonging to the Chemical Society of London, and Sir Christopher Ingold, he was from University College of London. So they have given that absolute configuration, and they were not knowing these things, right and left. Just they have given their initials, and how the coincidence says it having that correlation with your right and left. Now this V Prelock in 1906, and he and the R and S isomers, they were developed, and the CIP system most frequently used for designating absolute configuration of chiral compounds, that was proposed by this. Now here this R and S isomers, so they have proposed the sequence rules. You might be knowing this, but it is having the significance with our stereochemical designing. And they have arranged the ligands associated with an element of chirality into order of priority. And they have postulated priority rules. So where higher atomic number is given higher priority, and higher atomic mass is given higher priority, so that you can correlate. So here that R and S isomers, you can correlate with cis and trans. So that priority they are mentioning, RR is preferred over SS, then RS or this SR, and you can correlate with the elements iodine, bromine, chlorine, and view the molecule with the lowest priority group pointing away from the viewer, and count the remaining ligand in order of decreasing priority. So here in that case, the example is your bromochloroiodomethane, and here you can have that priority rule. Iodine is preferred, bromine, then comes chlorine, and then last is hydrogen. And if the path traced is clockwise, it will be called as the R, absolute configuration assigned. So that's why the first structure is R, clockwise path it is following. And if the path traced is counterclockwise, that is the S, absolute configuration, that is assigned going this anti-clockwise. And the priority you can correlate here. The stick ball model, how it looks, that you can have it. And the statement that I have made, atoms priority with atomic number, atomic weight, you can have it. Hydrogen, that is the lowest, having atomic number 1 and atomic weight 1.008. So it is placed in priority at the last. And based on that, the arrow are put. And based on that, you can design whether that molecule is R and S. And it is very significant in designing drug molecules and correlating with the pharmacological activity. So based on that, the absolute configuration to butanol also you can give, and you can have with the correlation with relative configuration, you can call that molecule as R2-butanol and S2-butanol, depending upon the priorities and the group attached, and you can put the sign clockwise or anti-clockwise, or you can put that arrow for that butanol molecule, and you can have the correlation with relative configuration and absolute configuration. Here relative configuration that we have designed a negative sign, and absolute configuration we have put the sign R and S. Slides are visible, no? Now the configuration parts ends here, and now starts the conformational part. So confirming something, after configuration, after probability, you have to confirm the things. So or you have to validate the things. In pharmaceutical analysis, we validate. So that validation of configuration is done by confirming, and that will be called as your conformational stereoisomers. And conformational stereoisomers, they are classified as eclipse, staggered, skew, anti, gauge, then the important chair, boat, twist boat, and half chair. So all these are actually coming here in that here conformational stereoisomers. Now the conformations, a different arrangement of atoms that can be converted into one another by rotation about single bond, that will be called as conformation. And how that Androin formula or the Newman projection of that eclipse conformation of ethane looks, you can see it here. Actually overlapping of that hydrogen atom is there, and that is not required while drug designing molecule. Eclipse, grahan, ठीक है ना? So grahan, whenever grahan is there in our earth or in between sun and this your moon, earth comes, eclipse is there. So that is a phenomena, and we don't consider that eclipse as a good sign. So same way for organic molecules also, correct? So here in that case, now staggered conformation, staggered apart. The infinity of intermediate conformations, they are called as Q conformation, and the staggered conformation, they are placed apart. Now, whenever say your Earth, Moon, or Sun, they are placed apart, stability is there. So, based on that, in molecules also, if that molecule has functional groups that are attached, so they are placed apart, so they will be stable. Now here the anti-conformation, the methyl group, they are on opposite side in Newman projection for the normal butane. Then the Gauge conformation, the intermediates, where in that case the van der Waals forces, repulsion, that steric repulsion, strain, steric strain, torsional strain, or the crowding of methyl group, and the mirror image of conformation enhancement and anti-Gauge, they are not mirror image of conformers of your diastereomers. In that Gauge, you can find it out, the stable structure will be obtained. Now the conformational isomers. Now here we are studying with conformational studies. So the isomers will be called as conformers, correct? Chair conformer, boat conformer. So they are actually isomers. But while conforming the structure, it will be called as conformer. So based on that, the different conformations that corresponds to energy minima, they will be called as conformational isomers or conformers. And conformational isomers, they will be interconvertible by rapid rotation about one or more single bond. And based on that, one slide I have taken from Morrison and Boyd, where potential energy changes during rotation about the carbon-carbon single bond of ethane. You can see the staggered form, they are lying at the bottom or having very less energy. And if you rotate it, eclipse, grahan that I have shown, so they will be jumbling, crowding, and it requires a potential energy of 3 kilocalories, and that will be highly unstable. So graphically also you can represent in Newman projection the aliphatic molecule, the ethane molecule, and you can have correlation. Now the same thing you can have with this for your how you rotate in the normal butane, where that anti, then Gauge, and the structure that we are lying, and you can have the comparison. And in that case, here if you rotate it, the anti structure overlapping will be occurring, and you will getting an unstable molecule. Then Gauge again coming to the bottom, then again the molecules that are coming eclipse form, again it requires energy, instability, or more it can be reflected in that cyclohexane molecule, the potential energy graph or the relationship among conformations of cyclohexane. Now the chair form, you can see on the graph of potential energy, it is lying at the bottom. Half chair, it requires 11 kilocalories energy, unstable. Then the boat, twist boat, again it will require the energy, and here they will be behaving like an unstable molecule. Now here the chair and boat form of conformations of cyclohexane I have shown with the structure and the stick ball model. Now here the twist boat and half chair, how it looks. Now an important structure of cyclohexane showing axial and equatorial bond. Now the bonds which go through axis, they will be called as axial, and the bonds which go through equatorial, they will be called as equatorial, represented by E. And here you can have it, the axial bonds, you can compare that bonds with two carbon atoms in surroundings. So one axial bond, if it is coming above the plane of the ring, the subsequent adjacent carbon atom, that axial bond will be going below plane of the ring, and that is denoted by the green line, solid green line coming above plane of the ring, axial bond, and dotted line subsequently below plane of the ring, dotted line, alpha bond. So it continues at the adjacent carbon atom. The next again it will be having the correlation. So that axial bonds, they are actually transdiaxial. Anyway, you can compare transdiaxial, transdiaxial, correct? And the solid line that is represented in cyclohexane, that is coming toward the viewer, projected toward the viewer. And the equatorial bond, they are represented by red line, and with solid line above plane of the ring and dotted line below plane of the ring. So at each carbon atom, one axial bond, one equatorial bond, and two covalent bond, they are attached with that next carbon atom. So this structures actually explains the stereochemistry of cyclohexane, the bonds, how they are arranged, axial and equatorial bond, and they play vital role in drug designing. If you understand the phenomena of axial and equatorial, then transdiaxial, then equatorial bonds, the clarity for designing the drug molecules or the activity you can design or you can control through this cyclohexane structure. Now the chair form, we call it as most stable conformation. Why? Because of the structure that I have shown, which is and symmetrical structure, compact structure. You can see it. It is a compact structure, symmetrical structure. Then completely free of strain, angle, torsion, van der Waals forces. You can see it. All bonds, they are placed apart. So no interaction. So stability will be more. And every angle is tetrahedral angle. The first slide that I have shown. So tetrahedral carbon atom perfectly maintained. And every C bond is precise staggered and energy minima and no crowding of hydrogen bond. So that's why this thing contribute toward the stability. And everything just fit geometrical demands, architectural perfection. The building, before designing, architect gives plan. So same is the case for the molecules. So here that cyclohexane molecule having architectural perfection and cyclohexane chair in the structure, which is also present in the diamond, and diamond most stable form of carbon and the hardest substance here in that case, and replacing one methylene group with oxygen make up the most abundant building block of the organic world, that is the glucose molecule, D-glucose molecule. Just replacing one carbon atom with oxygen in that cyclohexane ring, that will be forming a basic skeleton of your glucose molecule. So based on that, you can have that correlation of your cyclohexane with the glucose molecule. Now here I have shown one slide that chair form most stable conformation, that having appearance of chair form in diamond. You can see all chairs, they are fit perfectly and they are providing the sturdity to the diamond molecule. Diamond contains cyclohexane itself. Then coming to the sugar molecule, the chair form most stable conformation. Just now I said replacing one carbon atom with oxygen, you get that glucose molecule, and it is its cyclic structure. So it will be called as pyranose, glucopyranose, glucose structure, and alpha D glucopyranose. Alpha, that indicate that hydroxy group at the first carbon atom in the numbering, that is down, axial, that I have shown, alpha bond. Capital D, here in that case, in cyclic structure, the bulky group coming above plane of the ring, that will be called as D. And the positive sign indicating rotating plane polarized line of that glucose molecule in polarimeter on clockwise direction. So that becomes your alpha D glucopyranose with positive sign. And appearance of chair form, alpha D glucopyranose, the stable molecule. So that you can have it. How it looks in that stick ball model, also you can have that idea. Then the Fischer projection, open chain structure of glucose, how it looks. That also depicts the alpha and beta D glucose. So based on that, alpha at the first chiral carbon atom, hydroxy group right side, and D, capital D, farthermost chiral carbon atom having bulky group on right side. Same is the case for beta. First chiral carbon atom having hydroxy group on your left side, and the D series, farthermost chiral carbon atom having hydroxy group on your this right side. So that is Fischer notation, open chain structure. As such, glucose doesn't exist in open chain structure, but while developing the structure of glucose or studying the structure, Fischer has denoted first this Fischer projection. Then comes the here alpha L and beta L, and that way also you can have it. And after that, when we try to apply stereochemistry here to glucose molecule, so what happens? That molecule actually come to be a cyclic molecule, and Haworth has projected the structure, and he has called that as Haworth projection. And that Haworth projection is actually existing in chair conformer. So that I have correlated. So how we have started with this alpha D glucose, and we have converted that to the cyclic structure Haworth projection, and applying stereochemistry, it comes to chair conformation, alpha D glucopyranose, how it looks, the perfect structure, and it is having correlation. Whichever groups they are down, they comes in down in chair conformer, and whichever are above plane of the ring, they come in above plane of the ring. and based on that, the stereochemistry continues. Alpha D positive sign, and here in that case, if open structure, that is called as glucose, and if it is cyclic, it is called as glucopyranose. Pyrene ring is present, 6-membered ring with one oxygen atom, and the structure will be your ending with carbohydrates, so that becomes pyranose, and it is a glucose. So glucopyranose, how that nomenclature is there. I hope you are getting it. Now coming to the correlation, you can have it interconversion also, you can have it for alpha L. So same thing you can apply here in that case. So L, whatever I have mentioned, L means bulky group down, and alpha means hydroxy group down. Then the beta at first, hydroxy group at above. So based on that beta, and you can have that beta L also. Now here in that case, here we come to the end of the drugs or the organic compounds. And based on this, certain molecules, how they are regulated with the stereochemistry and which came into market and will exert its activity. So certain drug molecules I will show you in that slides, in the subsequent slides. So I hope up till this, the things that I have covered are clear. Now the drug molecules. Now the very first molecule, that is actually the derivative of benzoic acid, that is aspirin, or you can call it as your, here in that case, acetyl salicylic acid, that is aspirin. So here used in market for your analgesic antipyretic activity or this cardiovascular activity or for blood thinning purpose, generally prescribed by the doctors in that case to have the thinning of the blood. So this 2-acetyloxybenzoic acid, how it looks in stereochemistry. Here in that case, you can have that idea. Benzene, flat structure. Now here stereochemistry in that molecule is regulated by the side chain, and side chain are actually responsible for regulating the activity. The very first molecule that I have shown. Now the very common molecule that was also prescribed in the COVID period, that was paracetamol in different doses form. So that different doses form, 500 paracetamol was there, 650 was there, Dolo was there, Calpol was there, your Pacimol was there, Crocin was there. All this contained, all brands that contain the basic chemical moiety, that was paracetamol. And here this paracetamol, how it looks, again it is a flat structure, but the stereochemistry is regulated by the side chain. So that side chain, that is of the acetamide. Chemically it is N4-hydroxyphenyl acetamide, paracetamol, or an N-acetyl derivative here in that case. So how it looks and how the stereochemistry here will be regulated by the side chain. Benzene is a flat structure, so benzene doesn't play a vital role. It will be in two-dimensional way. But the side chain, that side chain is your acetamide chain, or here in that case, N-acetyl group or that amino acetyl group, that will be actually regulating, and it is used for the your analgesic as well as antipyretic purpose. And it was a very useful drug in that COVID period or the COVID treatment. So it also regulating the stereochemistry. So the importance you can correlate, the stereochemical trends you can have it for that molecule. Then comes the another molecule, which is also used for a strong pain killing purpose. And this molecule, it is also available in form of your tablets, oral dosage form. It is also available in form of creams, ointments. It is also available in form of injections. It is also available in form of your drops. So it is having a wide variety, but longer use of this causes and toxic effects. So longer use should be avoided. Diclofenac molecule that is present in your Combiflam tablet. Now this drug molecule having two benzene ring, flatness is more, and the side chain, that is of your here it is having 2,6-dichlorophenyl aminophenyl acetic acid is the side chain. So acetic acid is actually regulating the stereochemistry, and based on that you can have another molecule which came into existence, that was aciclofenac. You can see it, aciclofenac. So aciclofenac is just an acetyl derivative, or here it is an acetyl oxyacetic acid from your diclofenac itself. Your aciclofenac came into existence. Zerodol that contains acinac, that contains this aciclofenac in market. These tablets are available. So it is actually a derivative or having less side effects. So that's why Zerodol is more preferred over the plain diclofenac. So you can have that idea. It is also available in combination with serratiopeptidase Zerodol SP is there, or with other molecules you can have it. Acinec P with paracetamol also you can have it. So stereochemistry will be regulated by the side chain. So aceclofenac, it is actually and 2,2,6 dichlorophenyl, basically diclofenac derivative, but it is acetyl oxide derivative of your acetic acid. So that is aceclofenac. So that came through stereochemical changes, stereochemical trends, and nowadays it is widely used. So you can have the justification of that stereochemistry for designing the drug molecules. Based on that, I have covered certain molecules. Now, another molecule which is commonly used in day-to-day this practice by doctors or by patients, or it is also used in OTC product over the counter, that is omeprazole. Generally, the chemist gives OME when as complaint the patient gives. So OME contains omeprazole. OMEs contains omeprazole. So omeprazole, again, it is a flat structure having bulky molecule, three, one is benzene and one is pyridine and one is imidazole. So that will be reflected. So benzimidazole is reflected. The stick ball model, how it looks. And chemically it is 5-methoxy, 2,4-methoxy, 3,5-dimethyl pyridine, methyl sulfonyl, 1H benzimidazole. So this omeprazole, it is an H2 antagonist or directly act on the H2 pump or the hydrogen pump. So whenever in body acid or acidity occurs, so acidity is due to hydrogen ion, and hydrogen ion that is actually coming from secretion of acid. So within our body in stomach, HCl is secreted, or the medicines like paracetamol we take, so it is actually causing bleeding in the stomach. So that bleeding is due to the secretion of that hydrochloric acid. So you have to neutralize that. So this is here H2 antagonist omeprazole. So in every prescription you will find medicines causes acidity, so that acidity can be tackled by this omeprazole. So it is having an stereochemical base, you can have that. Then the cetrazine, the anti-allergic molecule, preferably H1 antagonist it is. So again, it is a complex molecule. Again, coming through drug designing, levocetrazine, the levo part. Levocetrazine came into existence while taking into consideration the stereochemical changes or stereochemical trends while designing this molecule. So as such, cetrazine, again, it is an bulky aromatic molecule where it is 2,2,4 chlorophenyl phenyl methyl. It is having piperazine, aromatic ring, piperazine heterocyclic molecule, ethoxy acetic acid. Again, acetic acid comes. So here that cetrazine molecule. And nowadays the levocetrazine, the levo part. So here stereochemistry is regulated by the carbon atom, where that is attached to this benzene ring. So just the levo part will be there, and it will have much more effect. So here in that case, levocetrazine will be there. Then our normal molecule, neurotransmitter, adrenaline, having adrenergic activity, it is also having that side chain. Aromatic part doesn't regulate stereochemistry. The side chain, that is, the side chain is methyl amino ethyl. So that side chain will be regulating the stereochemistry, and you will getting that adrenergic activity I have shown with the dotted H and the solid OH. Then comes your acetylcholine, again a neurotransmitter, where it is aliphatic molecule, 2-acetyl oxy, then N trimethylanium acetylcholine. So acetylcholine, it is actually a neurotransmitter. Within our body, it is secreted, having stereochemistry, and you can regulate the things, the stick ball models. Then comes your atropine. Atropine, adrenergic activity here in that case, here at that particular point. Again, stereochemical molecule. It is an 8-methyl 8-aza bicyclo octyl 3-hydroxy 2-phenyl propionate derivative. And most of the eye drops that contains for that adrenergic activity, that is regulated by atropine, a complex molecule where stereochemistry will be regulated by the chiral atom, and the side chain, that side chain is there of aza bicyclo. And this is my last slide. So up till now, we have started with your chemistry, then we have started with stereochemistry, then configurations we have covered, and the chemistry was starting with carbon compounds, and they are having correlation with configuration and conformations. And chirality we have covered. So here we are starting everything with C. Confusion also start with C. Then chemistry also start with C. Carbon compounds, they also start with C. Configuration, conformation, chirality. And you can correlate this with stereochemistry. If you combine two C, one straight and one opposite, it gives S. So that stereochemistry is also controlled by the C, or also controlled by the chemistry, or also controlled by the carbon compounds, also controlled by the chirality or the configuration or the conformations. So that is the significance of the your chemical compounds, correct? Or the organic compounds. If you join 2C, O comes. So there also the contribution of C is there. So thank you very much. Now the session is open for question answers. Kale madam.
Yes, sir.
Thank you, sir. Thank you. Thank you
You have
very
a
much,
question?
sir. Yes. Yes, sir. There is a question.
Yeah.
How stereochemistry plays role in biological active substances?
Yes, definitely. I have taken that example of ethambutol. The very first or second slide, you can come to that slide, ethambutol. Now here I have shown the outcomes. Now here the example of ethambutol. Now ethambutol, if you give an absolute configuration, and that absolute configuration here, suppose if that is having that absolute ethambutol, simple molecule, it is an hydroxy derivative of ethane, and that ethambutol is there. If the absolute configuration is SS and rotating the plane polarized in positive direction, so it will have the biological activity against this Mycobacterium tuberculosis, and it will be used to treat tuberculosis. And if you change the absolute configuration and if you revert that, and here in that case that hydroxy group, if you convert it to right side, so that will be RR, and rotating the plane polarization negative sign, and that ethambutol will be reverting the activity and it might cause blindness. So it is having a much more significance here in that case. Same is the example for that dextropropoxyphene, which is having analgesic effect, and this levopropoxyphene that will have an antitussive effect. Then your levocitrazine, the levo derivative, it is having much more greater activity, anti-allergic activity as compared to cetrazine. So that's why that levocitrazine is preferred. Levocet that contains levocitrazine. So definitely, stereochemistry is actually regulating the biological activity. Without stereochemistry, designing of biological activity for drug molecules is not at all possible. So that is the significance of that stereochemistry. It is clear? Participants?
Sir, there is another question from Akshay
Yeah, yeah.
Rohan. How,
Ah.
how we can determine stability and reactivity of pharmaceutical preparations by using stereochemistry?
Stability of pharmaceuticals.
Yes, sir.
Now here in that
Pharmaceutical
case,
preparations.
I have mentioned about the conformations, correct? In that chair and boat. Now suppose if any drug molecule or a steroid molecule, you can take cholesterol itself. Suppose if that cholesterol having cyclopentano per hydrophenanthrin ring, and in that case the three rings they are fusing, and their fusion, if they are the chair form they are fusing and they are transdiaxial, so in that case the stability of that molecule while in the body will be much more, and it can easily cross blood brain barriers, because in chair form and that transdiaxial form of the fusion, the compound or the molecules or the functional group they are attached, they are placed apart, and if they are placed apart they will have no interaction while exerting its biological activity, and they will don't have any this shielding effect, crowding effect, or no torsional effect or no van der Waal effect, and they can exert their activity in the best form. And if you convert that to boat form, if the chair form is converted to boat form, what will happen in that case? Chair form, boat form, low. In boat form, the molecules or the functional groups that are attached to the this compound, in that case, they will come closer and they will have an interaction, and that interaction will cause an toxic effect, and it will affect in that pharmaceutical formulations also. So based on that, we have to select such a stereochemical form that will have and much more stable effect, and it will not affect the stability while exerting its biological activity. Here you can have it. Here in that case, I have shown this. Now here, this is chair and boat form. Now here the model that I have shown here. So in chair form, you can find it out. If you attach the functional groups to this, they will be placed apart. Here, no interaction and nothing will be there. But in case of boat, if you convert to boat, the functional groups that are attached, they will come closer. And here in that case, it will come have an interaction and they will affect the stability also. Next slide. 1 minute. Here I have shown that chair form most stable conformation. Here in that case, the chair form structure is more compact, completely free from strain angle or the torsional or van der Waals forces, and every angle is tetrahedral angle, and every carbon bond is precise staggered and energy minima, and no crowding of hydrogen bond. And based on that, here in that case, you can call that molecule as a stable molecule. पीछे लो ना. स्लाइड आगे लेना. Now here cyclohexane chair, the structure that is having just fitting everything, and you can have the stability of that molecule. And I have mentioned that if you replace one carbon atom with oxygen, you get and the basic skeleton of your glucose molecule. Yes. Any next question?
Yes, sir. There is another question. It is,
Yeah.
is it necessary to separate isomeric mixture of any drug in which one of the active form and another one is inactive form?
Yes, it is necessary to separate. If one is active and other is non-active, so active form has to be separated. So that separation can be done by a resoluting mixture of your tartaric acid or chlorosulfuric acid, and with that you can separate the isomers. You can separate positive isomer, negative isomer, and with that you can continue further for your biological activity. So separation is must. Without that, you can't go for your pharmacological activity. Yes. Are you able to hear?
Thank you. Thank you very much, sir, for your valuable and informative session on stereochemical trends in pharmaceutical science and research. Next, I would like to...
Okay. From my side, thank you everybody for listening patiently. And due to some technical error or due to some internet problem in initial, some slides were not able to share with you. For that, I am extremely sorry. And once again, I thanks to the organizer for inviting me as a guest speaker. And one of my student, Dr. Ashok Narute, is I think staff member there and who has coordinated this thing with me very nicely. So my thanks are also due to him. My thanks are also due to the college principal, Dr. Angadi sir, who has given me chance. And I also thank to the management and to that organizing team, Kale madam, then that Sana Sheikh madam, who has introduced me. And thanks to the participants, those who have listened me patiently. I hope this webinar will be helpful to the participants in their future. I wish them all the best. And with this, I conclude. Thank you very much.
Thank you, sir. Now I invite Ms.
And if you want the slides, I can share the slides with you. Thank you.
Okay. Now I invite Ms. Gayatri Dedwal to propose vote of thanks. Over to you, Gayatri.
Very good morning to one and all. It's my privilege to propose vote of thanks. On behalf of Yash Institute of Pharmacy, Aurangabad, I would like to thank today's honorable chief guest, Dr. Pramod Khedekar sir, for not only sparing his invaluable time for us to grace this occasion, but also for enlightening us with his commendable talk on the topic Stereochemical Trends in Pharmaceutical Science and Research. Sir, we are highly obliged by your guidance and valuable presentation. Sir, you have enlightened us with your precious knowledgeable words like how stereochemistry trends plays an important role in pharmaceutical science and research, and very different concepts of stereochemistry like conformations and how racemic modification plays roles in separating stereochemical molecules and significations of stereochemistry. So you have rightly stressed and talked about how stereochemistry plays a role in drug repurposing and for developing antiviral drugs in short period of time, and how stereochemical trends are widely used for designing of drugs and as a tool for research. Which this session we felt was very informative, sir. Thank you so much. I would like to express my most sincere thanks to our respected principal, Dr. S.S. Angadi sir, and all our teachers and non-teaching staff. My deep sense of appreciation goes to all the participants who have attended this webinar with all the great enthusiasm. Thank you, everyone. Thank you.
Thank you, Gayatri. As a token of appreciation, sir, I request you to accept appreciation certificate on behalf of Yash Institute of Pharmacy, Aurangabad.
दोन मिनिटं थांबा म्हणा सर, आमचा वेबिनार सुरू आहे. 2 मिनिटं थांबा म्हणा.
सगळ्या फॅकल्टीजला पण सर, सगळ्या फॅकल्टीज
Certificate on behalf of Yash Institute of Pharmacy, Aurangabad. Thank you, sir.
कोणी सांगा आणि व्हॉट्सअपवर सांगून द्या.
Next session will start on sharp 12 noon.
Now I hand over the charge to Miss Dr. Vandana Patil, ma'am. Over to you, ma'am.
Thank you, Suvarna ma'am. A warm greeting to today's speaker and participants. After a very informative session of Dr. Pramod B. Khedekar sir on stereochemistry, let's move to our next session. To conduct this session, we have versatile and dynamic Dr. B. Geeta ma'am, Professor and Head of Department of Pharmaceutical Analysis from Sri Abhirami College of Pharmacy, Coimbatore. I would like to request Ms. Suvarna Kai ma'am to introduce our speaker, Dr. B. Geeta ma'am. Over to you, ma'am.
Thank you, ma'am. It gives me an immense pleasure to introduce our today's speaker, Dr. B. Geeta ma'am. She is presently working as professor and department head of pharmaceutical analysis at Sri Abhirami College of Pharmacy, Coimbatore. Ma'am has completed her PhD and M Pharmacy in pharmaceutical chemistry from JSS College of Pharmacy, Uti, the Tamil Nadu Dr. MGR Medical University, Chennai. She has completed her B Pharmacy and D Pharmacy from Madurai Medical College, Madurai, from the Tamil Nadu Dr. MGR Medical University, Chennai, and she has qualified GATE examination in 2001 with percentile 79.23. Ma'am has around 31 years of work experience and held positions like Vice Principal, Professor, Associate Professor, Assistant Professor, Hospital Pharmacist, and many more. She is versatile in subjects like pharmaceutical organic chemistry, medicinal and synthetic chemistry, pharmaceutical analysis, modern pharmaceutical analytical technique, and chemistry of natural product. Her area of interest in research are isolation and characterization of phytoconstituents using chromatographic technique like column chromatography, preparative TLCs, etc., and their purification techniques. Biological evaluation of potent extract and isolated constituents for anti-inflammatory and hepatoprotective activities using standard in vivo methods. Analytical method development for assay of drug products by high performance liquid chromatography, UV, and colorimetric method, and in vitro antioxidant assay to determine the potency of plant extracts. Dr. B. Geeta ma'am is expertise in handling sophisticated instruments like UV, FTIR, and HPLC. Ma'am has supervised around 18 research projects at UG and PG level. Some of her research projects are phytochemical and biological investigation of medicinal plants, microwave extraction of phytoconstituents, a green high-tech approach, and many more. On her credit, she has received Best Paper Award in Indian Journal of Pharmaceutical and Educational Research for paper entitled Microwave Assisted Fast Extraction of Mucilages and Pectins in 2010. She was coordinator for national level webinar entitled Chemistry and Biology of Drinking Water in 2020. She was also a resource person at international conferences on standardization of herbals and delivered a talk on phytochemistry, a green way to find a lead in drug discovery. She delivered online guest lectures in national webinar series and short-term training programs in the year 2020. Dr. B. Geeta ma'am has participated and attended various conferences, seminars, workshops, and short training programs at state, national, and international level. Ma'am has published 10 research papers in international and national journals. Thank you, ma'am. Over to you, Patil ma'am.
Thank you, Suvarna ma'am. I would like to request Dr. B. Geeta ma'am to start the session. We are eager to hear you. Ma'am, over to you.
Am I audible, ma'am?
Ma'am, you are audible, but voice is very low.
Okay.
Please share your screen.
Excuse me. Now, am I audible?
Yes, ma'am, you are audible, but voice is very low.
Very low. I'll correct, sir.
Yes.
One second, I'll correct.
Hello? Yes,
Sir?
Yes. It
Yes,
is-
sir. Now, is it audible, sir?
Yes, yes. Audible, ma'am.
Okay. First
You
of
can
all, I
share your
would.
presentation, ma'am.
Yes, sir.
You can share your presentation.
Okay, sir. First of all, I would like to thank for a wonderful introduction about me, which gives me a lot of enthusiasm in working towards this field. I thank Vandana Patil ma'am for giving me a beautiful introduction. I thank Yash Institute of Pharmacy for giving me this wonderful opportunity. A very happy and good afternoon to one and all present over here. Myself, Dr. Geeta, I'm going to share my practical experience with you on phytochemical research. If I could share and if I could make an interest in one particular participant, I hope I have done my duty well. So I'm submitting my pronouns to Saraswati Mata, and I'm submitting my thanks to the organizing team, the principal, and all the participants. Now I'm going to start my presentation on the significance of phytochemical research towards drug discovery. One second. I'm sorry, I'll take 2 minutes to correct this.
Okay, ma'am. No problem. Hello. Geeta ma'am,
Yes,
can I share your presentation from my side?
yeah, yeah, please.
Okay.
Excuse me.
Yes, ma'am. Hello.
Is it visible now?
Yes, yes, it is visible.
Okay.
Yeah, madam, make you can make it full screen.
Okay. Sorry, very sorry for this technical issue and for the time delay. The title is Significance of Phytochemical Research in the Drug Discovery.
Hello, Geeta ma'am,
Yes.
make it presentation mode. Okay, okay, ma'am. Yes, yes.
So the topic is significance of phytochemical research in the drug discovery. So what are phytoconstituents means? The chemicals which are present in the plants. So when we take the natural product drug discovery, we could see that there are many constituents present in the nature. So Mother Nature has a set of chemicals which we cannot imagine in our brain. So with this aim, this topic I have chosen to initiate some of the researchers towards our traditional medicines and plant medicines. So myself, Dr. Geeta, I have told already. Next slide. So the introduction part is the plant's importance. Plants, it's an integral part of ancient culture of medicine. Plants has invaluable components for the development of new drugs. And it's a treasure of phytoconstituents. It has a very high molecular architecture, which we cannot imagine by a synthetic laboratory. And when you see the plants and plant product drugs, we can see a very complex structure which is made up of more elements which is fitting at the receptor site. So it is the plant chemicals or the phytochemicals or the natural products are the building blocks for therapeutic activity. So the modern techniques, whatever we are using from a plant to a drug is separation, structural elucidation, screening, combinatorial synthesis, and source of drugs. The plant products not only serving as a drug in our day-to-day life, they act as the nutraceuticals, and in all the throughout the world, we have the dietary supplements as well as the nutraceuticals, which substitute or which helps us to serve our life. Coming to the next slide, the plants, whatever I have said so far, the same thing. The plants have been an integral part of the ancient culture, and it acts as a treasure, and it produces the molecular architecture. Phytochemicals are a group of non-nutrient bioactive compounds, and they are found naturally in plant parts such as flowers, leaves, fruits, roots, etc. In India, almost 95% of the prescriptions were plant-based products, which are like Ayush, Ayurveda, Unani, Homeopathy, Siddha. So now it's essential, and we have plenty of plant resources throughout India, which we can identify properly and isolate the phytoconstituent and make it a novel molecule for the treatment of various different diseases. So next slide, please. So in order to have an interest over the plant-based drugs, I have chosen some of the anti-cancer drugs, which are proved to be very effective at therapeutic levels. If you see the paclitaxel derivatives and the story of the Taxol converted to paclitaxel, it's a long history and dedication of the scientists to get this structure. And the next tree is the happy tree, which is called as botanically known as Camphothecia acuminata. And the next one is the American May apple, which is called as the Phodophyllum altatium. And then our last one is our own plant, which we are seeing as a weeds, and it is called as Catharanthus roseus, which belongs to the family Apocynaceae. So when we talk about the plants to the drugs, what are all the things we have to do is we need to go for various steps in the phytochemical research, which demands a lot of patience and also dedication towards the drug discovery. And also, as a phytochemical researcher, we have to concentrate on each and every fractions of the column chromatography, and we need to get into that. And when you see the discovery or the story of the Taxol, paclitaxel, the first structure, we can see that the paclitaxel structure is a transformation from the Taxol derivative, which is proved to be having more adverse effect. When we are as a pharmacist, when we see the development of the drug from the extract to a chemical structure, we could identify that structures like vincristine and vinblastine, before the hyphenated techniques and the integrated techniques, we were investing a lots of time and energy through chemical conformations. Thank God we have got now hyphenated techniques and also bioanalytical assays, which helps us to go with a good, remarkable time and drug discovery. And so these are the products which are accidentally discovered. One example is the vincristine and vinblastin. Earlier, the Catharanthus roseus has been studied for anti-diabetic study. So when in the lab, they could find that there were cytotoxic effect, then they have chosen that for anti-cancer activity. So I request all the students who are attending the participant, we have to be little alert in the laboratory where while we are going through the small changes which occurs accidentally. So if you see the penicillin discovery, the same thing it reflects. So the natural product discovery happens when we are as a phytochemical researcher, and also happily I can say while we are leaving that time a miracle will happen in your lab. So we have to be very, very cautious when we are dealing with all these extractive things. Next slide, please. So this is what the story, the successful story, where from vinca alkaloids to vincristine and vinblastin, and from the Taxus breviolea, which gives the paclitaxel derivatives and other derivatives. So these are the few examples which motivates us as a phytochemical researcher when we get like green color extract to a white color powder. What are all the struggles we have to do? This all these successful stories motivates us. So the significance of phytochemical research is one which gives a potent or which gives an imaginary molecule which fits well in the receptor site naturally. So we as a phytochemical researcher, we need to have this in mind and work with that. So these are other few examples which we know already. The common aspirin, which is an anti-inflammatory drug, which has been derived from the salicin, that is the lead compound. Similarly, artemisinin, I remember in our laboratory, artemisinin, while we are as a B pharmacy students, we do not know about artemisinin. Artemisia annua is the plant where artemisinin is the phytoconstituent which is used in the treatment of malaria. Like that, we have digoxin, a beautiful cardiovascular drug which is used in the congestive cardiac failure. So already I have told about this vincristine and vinblastin story. So next slide, please. So this is the part which I want to concentrate more. There are various steps involved in the phytochemical research. One is the plant selection, extraction methods, solvent selection, phytochemical analysis, in vitro methods, bioactivity guided isolation, and in vivo activity. So I want to tell you, if you are a phytochemical researcher, we have to start with the plant. We have to be very careful in all these steps. Number one is the plant selection. Number two is the extraction methods. Number three is the solvent selection. Number four is the phytochemical analysis. Number five is the in vitro methods. Number six is the bioactivity guided isolation and in vivo activity. Why I am saying this is, when you are selecting a particular plant and getting the work, without authentication, you will complete the work. Then the plant will be a different botanical species, which will claim which will claim wrong information to the scientific society. So plant selection, we have to select the correct plant from the literature. So going through the literature is the first challenging part every researcher should know. And I have an experience in the plant selection. I will discuss with you in the tips and tricks. Excuse me. The plants are selected based on the main four categories. One is the traditional usage. Second one is the ethnobotanical informations which are available in the Ayurvedic books. And we have pharmacopoeias, we have materia medica, we have all the informations available in the traditional books. So we have lots of critical Basho editions. So ethnobotanical informations will be available. So once we are concrete enough, like in deciding the potential activity or activity, pharmacological activity, then we can go through this Ayurvedic books and get it into the ethnobotanical informations. The traditional usages, for example, plenty of Siddha practitioners, homeopathic practitioners, and other all our ancestors are having more knowledge in this traditional and promisingly we will get a good molecule, but the traditional knowledge is not spread. That's why we are the ancestors or the early practitioners using Siddha medicines, they have not conveyed their knowledge 100% due to that the traditional practice or that plant surplus plants has gone into waste. The chemotaxonomical relationship, that is the chemical constituent and the taxonomical relationship based on the chemical and taxonomical relationship. For example, if a genus is having more amount of terpenoids, then we can tell that chemical constituent and the taxonomical constituent may be present in the genus. So when we select one species, the species is expected to contain that particular phytoconstituent. So chemotaxonomical means the chemical based on the phytochemical and the structure, we can conclude that the particular constituent may be enriched in that particular genus. The phytoconstituent analysis, which is the primary thing which we will do after a plant extraction, that will give you an idea about the nature of the constituent present, the secondary metabolite present. Ethnobotanical information. Shall I tell you at last some question I got? Excuse me. Okay. So there are some preliminary studies we are doing, collection and authentication. For example, you are going to work on a particular genera and species, get the information and the plant collection, go to the botanist, ask him with all the things. If you do not know anything also, go to the botanist and ask him about the accidental resins like exudates. We are having wonderful experience in the plant collection. If you are able to collect a particular plant which has not been reported so far and which is going to prove a biologically active, I can quote one example which I came across during my PhD, that is which is used Gilmania sylvestera, which is used in the anti-diabetic activity. So while we are going for a trip, the persons who are living around the place, they told that this is called as in Tamil, it is called as Chakkarai Kolli. That means it reduces the, while you are drinking 1 cup of glucose and you are eating the leaves of that particular plant, your glucose level will come to the normal. Then this was a playful experiment which makes other scientists to go through this plant in a detailed way, and we got the beautiful drug which we cannot imagine. So nowadays, while we are collecting the particular genus or species, we have to get authenticated with the botanist and Botanical Survey of India. For example, we have government bodies like Botanical Survey of India in various districts. So we have to go to that. They are there, they will have a herbarium, they will verify and they will tell you whether you have collected the correct plant. So that is the first part. And during collection, you have to take care about its for collection, and after collecting and authentication, you can go for the macroscopical studies which you are doing in your pharmacognostic laboratory. Similarly, you have to do with all these preliminary experiments. Then total values like ash values, extractive values before starting an experiment. We will take the plant powder, we will be dissolving in a particular solvent and we will be evaporating the solvent. So based on the extractive value, we will have a rough idea about the amount of the extract we will get for our macro analysis. So while we are doing physico-chemical constant, it is our high responsibility that we are doing it in a perfect way. So while you are doing, for example, you are doing alcoholic extractive value, that means your plant, you are getting more alcoholic extractive value. That means your plant is enriched with polar constituents. So that gives an inference initially. Every small observation inference has to be written in your observation notebook. So these are the things I have told you. What are the plant parts? So we are having, for example, certain plants like herbs, the whole plant we will be going for extraction. In certain other cases, there will be mentioned, our literature will be having a sufficient evidence like it's a root or it's a stem part or aerial part or leaf part. So while starting our research, we have to concentrate on the particular plant part which is enriched with more amount of phytoconstituents or therapeutic value. And we have to carefully choose our solvent for extraction based on the nature of the phytochemical analysis earlier done. There are various extraction procedures like hot extraction, oxalate extraction, maceration, cold maceration. So based on your area of interest, for example, you are concentrating on one particular alkaloidal fraction or you are concentrating on subphenols, then you have to choose the extraction procedure in that way. You do not know anything about the plant, then you have to go for continuous extraction procedures. So first, I would like to all the phytochemical researchers first concentrate on the solvent used for extraction. Why means like our labeled solvents will be like 99%, but when we check, we have to distill it, redistill it in order to avoid all other confusions, or we may lose some of the important constituents in future. That's why the solvent should be pure in nature and we have to check its purity before starting your research. So this is what I have told you earlier. The same thing is repeated here. Based on the origin, degree, moisture content, all this will give you a idea before going into the major research. So these things. What is the type of extraction you have planned? What is the time of extraction? And temperature, nature of the solvent concentration and polarity. Here I want to share my practical experience. If you are having a if you are having a mantle in your laboratory, the mantle will have 0 to 100. That doesn't indicate the temperature, it indicates the intensity of the mantle. So if you are a phytochemist, you have to check the mantle's temperature and using a thermometer and confirm it at what percentage of intensity, what temperature is there, then you have to start your work. So for example, certain mantles will have at 35%, it will have 60 degrees. So we have to be very careful in keeping the temperature. And also you have to know if your lab is, you are connecting with the siphonated tubes. So you have to be careful about with the water supply too, in order to get all the polar constituents in a activated way or in a natured way. If you keep it in a high temperature, they will go for degradation. So the temperature and the nature of the solvent and the concentration, all this determines your way of getting the phytoconstituent as the final stage. Next slide, please. So this is a small interpretation which helps you to know about the oxalate extraction, ultrasonication, all these things. There are certain phytoconstituents, for example, like mucilages and pectins, which are present in the plant and they are not getting affected with high temperature. So we can go for microwave assisted type. The disadvantage in microwave assisted is the evaporation is not proper. So like microwave assisted can go, we can go with the microwave assisted extraction for already known experiments like mucilages and pectins, where we can get the yield by 125% or 125 days. So this way This extraction techniques will help you. And ultrasonication and other supercritical fluid extraction. If we know the nature of the constituent present in the particular genus chosen for the study, then we can go for the hyphenated or the sophisticated type of extraction methods. Next slide, please. So this is what I have talked about. These are the various phytoconstituent present in the plant, like water-soluble, anthocyanins, starch, tannins, saponins. See, while you are doing the phytochemical analysis test using the normal procedures, we will follow like the standard procedure for the test for this phytoconstituent. If you are getting a foam-like thing, then if every part of your extract or plant is like foam, then saponin is present. Then you are getting you are taking a UV spectra in a diluted solution. You are able to see two peaks. That is a characteristic peak for flavonoid. So when we are getting like initial stage itself, we are confirming by the chemical test. So while we are knowing that you are having more amount of triterpenoids present, then you can very well choose the solvent as chloroform. If you know that the particular component is alkaloid, then you can go for ethanolic fractions. So our plant and the genus literature gives an information about the solvent to be chosen for the particular research. So this is the Soxhlet apparatus, where this is what I have told. Most of the mandals will have a thermostat condition, so your temperature will be maintained. So this outlet is connected to another Soxhlet, and then the outlet. So this way you have to do, where you can go for continuous extraction. So you will be using the same plant material starting from the non-polar to polar. For example, you will be starting from non-polar solvent, then you will be going with polarity scale and dielectric constant will vary. So you will be going with chloroform, ethyl acetate, methanol. So you will start with petroleum ether, then you will go in for this. And there is an apparatus down, it has been shown. This is called as a rota vapor. So you are concentrating your extract without affecting the phytoconstituents. For example, you are keeping a water bath and you are maintaining the temperature of this rotary evaporator, where your extract will be concentrated and your solvent will be collected as a distillation, same distillation apparatus with the thermostat condition. So the advantage is your extract will be concentrated soon. Otherwise, when we go for natural evaporation technique, it will take long time to concentrate the extract. And also when we use other type of conventional methods like petri dish method, you will take, it is very tedious to remove the extract from the containers. So rotavapor or rotavapor extractive values will be more useful when we have a particular plant which is less in our, for example, you have a herbs. The herbs are very less in weight. At that time, it's very difficult to prepare extract itself. So we should not lose the extract. So we have to concentrate using these type of apparatus. So these are, so the above methods are conventional, and nowadays they are using other innovative extraction technologies. Those are given below. Semi-bionic extraction methods, supercritical fluid methods, microwave assisted method, ultrasonic assisted method, molecular distillation method, and membrane separation technologies. So these innovation extraction, what is the advantages? Most of the phytoconstituents which we cannot extract, or all the phytoconstituents from the conventional extractive procedures, can be extracted by these innovative extraction technologies. So this is the advantages of this techniques. So normally, after completing your phytochemical test for flavonoids, test for alkaloids, test for steroids, etc., you will be going for 3 different analysis, which gives you an idea about which area you have to concentrate. For example, your extract is having a high phenol, high flavonoid, that means it is biologically active. So in the activity or the plants can be selected based on the phytoconstant present. We can go with these methods. The total phenolic content and the total flavonoid content can be estimated by the standard methods like Folin-Chiocalti method and aluminum chloride method. So these standard methods will give you an idea about how much amount of phenolic content is present and flavonoid contents. So if you have high amount of secondary metabolites present in the extract, if you have a high amount of secondary metabolite present in the extract, it gives you an idea that that particular extract can be taken up for biological studies in future. And also, next simplest assay is the total antioxidant capacity methods. So this is the procedure. This is a standard procedure where we have to go for the serial dilution method and we have to measure it. The color developed will be violet in color due to the phenolic OH. Along with that, we will use a calibration curve using gallic acid. If you get more amount equivalent to gallic acid, that means your extract is more rich in phenolics. Similarly, you have aluminum chloride method, which is used for the total flavonoid. So these are the 2 standard methods for phenolics and flavonoids. So this is given here for flavonoids and phenols. So if you are not aware about any traditional usage or it's a new plant which is reported less in the literature, you can go with this total phenolic estimation and total flavonoidal estimation. If your total phenolics and total flavonoid matches with that of the standard, that means you have chosen the correct plant. So this is how, when the traditional usage or the literature gives less idea, you can go with this total extractive values. Next slide, please. So these are the in vitro antioxidant activity assays carried out in the various extract. I'll tell you this. This will give you, while you are doing all these assays, they act by different mechanism. For example, ABTS assay, nitric oxide assay. These are all the assays where the free radical scavenging capacity of the extract is measured. So antioxidant assay, after completing an antioxidant assay, we will come to know that for example, we are starting the plant and we are having 4 continuous extract like petiether, chloroform, ethyl acetate, methanol. These assays will help us. If one extract is found to be more active in all the methods, then that particular extract can be chosen for in vivo activity. So the in vitro antioxidant activity has to be done. The criteria are the most important thing which we need to remember here is we have to choose the radical ion which we are going to do, and we have to repeat it minimum 3 times to get the concordant value. So if you have an ELISA reader, you can do it. For example, DPPK assay, if you do an UV spectrophotometer and an ELISA reader, you will get 12 average readings within no time. But if you take an UV spectrophotometer, the concentration of the diphenyl picryl hydrazine is very costly and you cannot repeat the experiment. So as a researcher, we have to plan this using our available apparatus in our laboratory setup. And if you have a biotechnology lab integrated, you can go with the ELISA reader type for DPPH assay, which saves a lot of time. And there the number of determinations will be 12. And you can compare more extracts in no time. So once you are planning all these extracts, you have 4 extracts, you can complete day by day and get the value. So if you are repeating 3-4 times, you will come to a conclusion that in my case, petroleum ether, out of the 4 extract chosen for my study, this ethyl acetate extract is going to be potent. So for this, these small things what we are doing will give us a better result in the till the histopathological study. So we have to concentrate in vitro antioxidant activity assays. The total antioxidant assay is measured by phosphomolybdenum method, which is a standard method which gives equivalent. And this total antioxidant is more means that particular extract is going to give you a potent result, or it is going to be biologically effective. Similarly, if you are choosing your studies or you are going to concentrate in anti-cancer, you can go for short-term cytotoxicity studies and the long-term cytotoxicity studies using standard methods like MTT assay and SRB assay. If you are doing a short-term cytotoxicity within a day, you are able to find that particular extract is having a good cytotoxicity effect towards cancerous cell lines and it is protective towards normal cell lines, then very well you can go with the long-term cytotoxicity studies. So if you are doing 7-8 methods, it's sufficient to write a paper too. So that's this way, if your extract is safe towards the normal cell lines and very much potent towards the cancerous cell lines, this idea you will get in the short term cytotoxicity and long term cytotoxicity assay methods. So these are the techniques which we are using for isolation of phytoconstituents. One is the column chromatography, thin layer chromatography, high performance thin layer chromatography, preparative HPLC, GCMS, LCMS. So normal phytochemistry labs will have column chromatography, which we are going with conventional method, where we will go from non-polar to polar. In that column chromatography, we will be choosing the solvents and the packed material, the silica gel or aluminum oxide, we have to decide based on the phytoconstituent analysis. So the packed material and the sieve size should be chosen according to the nature of the phytoconstituent. So in case of column chromatography, thin layer chromatography, HPTLC, preparative HPLC, GCMS, LCMS, all these are used in the isolation of phytoconstituents. So once the column chromatography is the basic tool to isolate the fractions, your fractions will be verified by thin layer chromatography. Then you will be pooling the fractions. And the high performance thin layer chromatography gives you an idea if a particular constituent or a flavonoid is enriched. You can compare like with quercetin, and you can get peak by peak matching technique, you will get an idea that whether my extract is having a flavonoidal compound. The preparative HPLC is one method. When you know a particular substance or a phytoconstituent is present in a abundant or high way, then you can go for a preparative HPLC method. And GCMS analysis and LCMS analysis we can do for the extract initially, and we can know the nature of the phytoconstituent based on the peaks and their molecular weight. So if you are getting more number of molecular weight, which varies by 14, that means that particular extract is going to have only aliphatic hydrocarbons. Similarly, by peak matching technique and the peaks can be matched with the available library data, and we can get an idea about the phytoconstituent present initially, which is going to save a lot of time during our further chromatographic techniques. So the GCMS and LCMS techniques are available in government bodies like IIT Chennai, IAC, and other government centers. It will be cheap, and I heard during my research we have some student interested labs are also there, so where they are charging less for this analysis. Coming to the column chromatography, this is what the heart of the phytochemistry lab. We have to take a column. First day you are going to do a column chromatography. Initial first day you have to wash the column, rinse it, keep it dry. If you have to decide which method you are going to do, whether you are going for a wet packing method or a dry packing method. Wet packing method or a dry packing method you have to decide, and that silica gel, the packing the adsorbent should be maintained at the temperature needed and should be free of water droplets. So we have to activate the silica gel by keeping in the hot air oven. So these are the very preliminary steps which helps us to prevent a huge loss in the phytoconstant analysis during the laboratory conditions. So we have to, as when you are doing a column chromatography, we need to focus on the mobile phase, that is the solvents. Already I have told you whether we have to check the purity of the solvent, and if possible we are doubting any purity, we have to distill it. We can go for double distillation and keep the solvents in a pure state. And if our fraction collectors and TLC plates, all these preliminary arrangements has to be done the previous day, so that to avoid the time consumption. So column chromatography is a beautiful technique which helps you to isolate the phytoconstant in a pure way. That is, after extraction, you are separating non-polar to polar. From that non-polar, if you take, for example, PET ether, you will have some 100 compounds. Column chromatographic fractions will help you to isolate that particular constant, phytoconstant. So column chromatography is an adsorption chromatographic technique. So this is the way. For example, you are taking a silica gel. You are going to start with N-hexane or petroleum ether. Okay, the first day you are dried in the oven. You come with a beaker, dissolve it in the particular non-polar solvent, pack it. You check whether you check whether the column is leaking or not. All these things you do, and first you fill the column till 3/4. After that, you keep your extract. You will not get many colorless compounds. This is a pictorial representation which shows color bands, but there are many colorless compounds which will get dissolved in a non-polar solvent, and you will get it in the beakers. So column fractions, we are getting, for example, you are collecting 25 ml. You are seeing the total volume of the column, the total ml of the solvent which is consumed by a column should be known earlier. And if it passed through the beds, we should understand that this is a free solvent coming out. Once the phytoconstant is getting separated after some colorless compounds, some slight yellow color compounds is coming out, means we should be very careful in the fraction collector. That means you are seeing one beaker. We are collecting 25 ml. Okay, in the 25 ml, you are seeing another 5 ml is coming in a different color. Immediately, you have to change the beaker. That avoids the tediousness in the separation. So all this fractions collected will be taken in a big TLC plate where we will keep the spots from fractions 1 to 10, 11 to 20, like that we will keep the fractions. And once we can see that all the spots are moving with similar number of spots, we can pool it. That is, for example, you are having first 10 fractions are showing 3 components. That means these 3 fractions, 10 ml, 10 ml, 10 ml, or 30 ml, 30 ml can be pooled together. Mixing up of the fractions is a very important tool in a column chromatography. We have to be very careful. The column fractions, whatever we are collecting, we can keep it in a TLC plate and check through the UV chamber. Colorless compounds, they will absorb in long or short wavelength, and it will give a different spots in the UV lights. So that way we can check it and we can pool it. So these are the various types, like gravity for column chromatography, flash column chromatography, vacuum liquid, and high HPLC. See, if you are having a column chromatography and you are seeing that in one particular beaker, you are seeing that the constant is chemically answering terpenoids, and also it is giving 2 spots as a major one, then that particular components can be chromatograph again, that is, we can go for 3-column chromatography. So these are the various points. The fractions collected in the TLC has to be pooled correctly, and the isolation can be, characterization can be done by UV, IR, HN and C13 NMR. When you know that particular fragments and by peak matching technique, we can conclude that my phyto constant is this by mass and C13. So C13 NMR will give you an idea about the number of carbon atoms. So nowadays we are having depth technique and enough technique, and in H1 NMR also we have normal H1 proton NMRs, which will give you the idea about the nucleus present and its environment. So the UV spectra helps you to find out, confirm whether the component is flavonoid, and IR gives you an idea about the functional group present in your molecule. So when we are doing an UV, IR, HN and C13 and mass, these 5 spectroscopic techniques, when it is integrated, you will get the molecular structure of your isolated compound. So this is what I have told you. When we are seeing some colors, this is, we will get an yellow color where you have more, when you have more number of spots, and those spots are showing similar type of chromatogram, then those fractions can be mixed very well. So this is a HPTLC equipment which helps you to find out. For example, if you have any plant chosen, it has one particular flavonoid content, you can go for a peak matching technique and you can isolate your compound similar to that or the same compound, and you can have the analytical concentration of that particular phytoconstant by peak matching technique, by developing the standard method using high performance thin layer chromatography. So the high performance thin layer chromatography gives an idea about the number of components present in the particular column fractions or else in the extract, which we have prepared by continuous hot percolation or maceration techniques. So this HPLC instrument, there are 2 types. One is analytical and other one is preparative. When we are particularly knowing that I have one particular fraction which is going to have only one compound, I have to remove only the trace impurities. I can go for the normal HPLC column which will not block. I can go with the highly diluted solution and go for the method developed already. So then we can verify, and there is a way, like there is a waste tube. The waste tube, in that waste tube, we can keep a test tube and we can collect our fractions. And sometimes, luckily, we will get one particular phytoconstant in that without any interference. So analytical HPLC, when we know that particular fraction is having only 1 or 2 components which will not interfere or block the column, then we can go with the highly diluted solution and check its purity. So when you have surplus quantity of that particular phytoconstant, this analytical HPLC serves as an important tool. And otherwise, you have one band which is more amount of particular phytoconstant, you can go for preparative HPLC, where the particular fraction can be isolated and separated. So this is GCMS analysis. Again, this gives you an initial idea about the particular phytoconstant, and this GCMS analysis is used for all volatile compounds, and their spectral analysis will give you, when we are doing GCMS analysis when your instrument is linked, we can get both the peaks as well as their molecular weight. So the purity will be enhanced, and your interpretation by GCMS analysis will be done with the already available literature library details. So this is LCMS. So once you are having the whatever fractions, whatever isolated constant is coming, you have analyzed through the mass spectroscopy. If it is a pure compound, it will give you a single peak which will confirm its purity, and through the mass analysis, the same can be interpreted by a peak matching technique, and the molecular ion peak will give you an idea about the compound isolated if it's a well-known compound. So this is how, these are the techniques which are helping us and which reduces the tediousness of characterizing the phytoconstituent very easily. So while as a phytochemical researcher, when you take a UV, IR, NMR mass spectroscopy and two-dimensional and LC-NMR and GC mass technique, you will get an idea about the isolated compound. Its fragmentation can be very easily interpreted. Once you know that the particular extract is proving to be biologically active, and that particularly through in vitro studies, for example, you have done all the antioxidant activities, one extract is proving very highly effective, it is equal to standard. I will take one example like DPPHSA. You have the standard like ascorbic acid. When we compare the ascorbic acid values or extract value is similar to that of the ascorbic acid, that means that particular extract is going to be potent. So similarly, we can choose the animal model based on the literature, and also we can choose the extract based on the in vitro results. So you are aiming for anti-cancer activity based on the long-term cytotoxicity effects, you can choose the extract. And you are getting in a particular fraction, you get one particular phytoconstant, that phytochemical constant can be analyzed as a single group along with the other groups which are used for standard normal, and it can be compared with the extract. So luckily, if you get a compound which is going to prove equally, then that particular constant can be subjected for further enzymatic analysis and we can proceed. So before starting our animal models, we'll be going for acute toxicity studies and for 24 hours, and we will be reporting, and long-term acute toxicity studies will be done, and then the animals, the number of animals survived will be taken into consideration. So if your extract is non-toxic in nature, the animals will survive. So we have to complete the acute toxicity studies for the selected species. Then the biological parameters, like you will have all the enzymatic values, it will be done through the estimation, biochemical estimation. Then you will be comparing this. Finally, you will go for the histopathological report, which proves the activity of the isolated phytoconstituent or the extract, which merits the advantage of the selected plant, which has been scientifically proven for further elongative studies. So all this in vivo methods has to be done carefully, and this histopathology will give you a correct idea about the cell degeneration process. It will give you an idea about the activity performed, like hepatoprotective activity or anti-cancer activity, etc. Next slide, please. So this is what nowadays they are combining the phytochemicals with all the known things, and genomics, proteomics, all this also combined, and we are going for computer aided drug design where we can get a phytoconstant and doing similar thing what we are doing with the synthetic thing, and now these innovative techniques will bring out or will reduce the tediousness involved in the conventional technique of isolation of phytoconstituent. That's why I have kept this slide. If you are very much interested in a phytochemical and you know that we are going to come with a molecule, novel molecule, then we can go for all these studies. So this is again the same thing is explained here. What are all the extraction methods recently available and how this recent technologies can be combined with the conventional procedures in order to get the phytoconstituent in a purified way. And this reduces the tediousness, and the biological assays available nowadays. We have all this biological assays which can be performed in microgram level or till picogram levels, which will reduce the tediousness of the high therapeutic screening assay methods will reduce the tediousness, and thereby definitely as a phytochemical researcher, the technology as well as the hyphenated methods and our brain, if put together, we can come out with a good novel molecule or a drug in the selected plan, which we are aiming for. Okay, this is some tricks and tips in phytochemical research. I want to share my practical experience. Whether time is there, sir? Excuse me?
Yes, ma'am.
Shall I share some of the tips and tricks in the research?
Yeah, definitely, ma'am.
Okay. Okay, I want to share some of the tricks. What is the trick is, you are collecting, for example, you are having one green color solution, imagine, in a test tube, and you have some crystals in that. You are, if you are going for solvent extraction, definitely you cannot take out the phytoconstant. I'll repeat, you are seeing some crystalline type or which can be easily removed in a test tube. You are seeing one test tube of extract which you have, fraction collected from the column. You are seeing that fraction after evaporation, you are seeing some crystals. What we have done is, really we have done this isolation by this technique. What is the technique is, we have taken a forceps and we have taken the center of the part and removed those crystals in a petri dish. We have taken and washed it, and you will not believe that forceps helped us. And sometimes we will have some jokes in our phytochemical laboratories. What is the joke is, you will keep all the column fractions in your cupboard, and you will come after a long days. So sometimes you would have done some antioxidant assay. This is what happened in my lab. We have taken some porcelain, some cover slips, and we are keeping the extract and dissolving the extract. And after that, we have forgotten to wash those things. Then my friend told that was crystalline compound, you may get alkali. Then I was thinking, okay, I got an alkali. After that, my B Farm student told, Madam, why you have broken all the cover slips and you have kept it in the beaker? This is what funny things will happen in a phytochemical research. And one more thing I want to add, some techniques we will learn, like there are false reports in paper chromatography. When you threw acetone in your, when you dissolve a particular extract in acetone and do a paper chromatography, you will get positive test with the drag and drops reagent. You can see the orange color spots. This also happened in our laboratory. We are doing paper chromatography with the compound, and we are seeing orange color spots. Finally, we could find out that this is not because of the phytoconstant present. This is because of the acetone. So like this, you will have lot many things in your lab. And in case you have you are having two compounds, you are identifying by a thin layer chromatography, their RF values are very much wider. Then what we can do is, we can go for a thin layer, preparative thin layer chromatography, which avoids most of the other tedious process. You can cut it and collect it in a beaker, and very well you can collect the phytoconstant by preparative TLC methods. So these are some of the tricks, and you may come out with many tricks in future, hopefully, which will motivate us for this. And we will, when we get a compound, that time we will be celebrating like anything. So these are the one novel compound. If you isolate in your PhD, that itself is a great credit for as a phytochemical researcher. So we have to be very careful while we are collecting fractions, and while we are having any closer RF values, then we can go for re-column chromatography very carefully with that particular fraction. These are some of my experience I want to share with the participants. Thank you for allowing me. So coming to the conclusion. So now we are going to conclude that phytochemical research, even it is a tedious process, but it has a very beautiful molecule which matches with the receptors which we cannot imagine. The beautiful example is our penicillins and cephalosporins. Similarly, the plant-based drug works are very tedious in nature. For the tediousness, we cannot miss our diamonds in that. So the nature is the best combinatorial chemist, and it has all answers for the mankind. So the various challenges, whatever we are facing towards our research, when we isolate the compounds, it will be we will be forgetting all these tediousness. So With this, I'm concluding my session of phytochemical research, like when we are able to isolate a particular compound or a novel compound which is going to be biologically active throughout our continuous research, that we are going to help our mankind. And as a pharmacist, as a healthcare professional, that is my aim at present. So this is what this is the technologies and all other hyphenated techniques is going to help us in doing this. Next slide, please. So natural product drug discovery, even phytochemical research, again, it's going to bloom, and we are going to come out with very beautiful like digoxin or vincristine or vinblastin or etoposide and other anti-cancer drugs. Like that, while we are starting our research, we have to think that we are going to become a scientist as a B.Pharm student or a M.Pharm student or a PhD student. All we have to have a great attitude. So that's all for today. I'm very much thankful to the organizing committee, the principal sir, and all beautiful madams of Yash Institute of Pharmacy, and all the beautiful participants and wonderful participants who listen this presentation in a very patient manner. And I take this opportunity to thank our principal management and other students of Sri Abhirami College of Pharmacy who has given me this chance to participate in your national webinar series. I also thank personally my friend Gajanan who has chosen me with some good thing in his mind, and I hope I have satisfied to my level best. And if I have done any mistakes, I'll correct it in future. So that's all for today. I thank one and all. I thank Ajanan and Shushma for remembering me in this. I thank the principal management and the team, very effective team of Yash Institute of Pharmacy for giving me this wonderful opportunity. If a participant is interested towards phytochemical research, I am very much happy to help you in future. Thank you one and all.
Thank you, ma'am, for giving your valuable insights on this topic, significance of phytochemical research in drug discovery, along with the tips and tricks which are very helpful in phytochemical research. Now, ma'am, it's time for questions from the participants. May I ask to you, ma'am?
Yes, ma'am.
So
Yes, ma'am.
yeah. Ma'am, can you suggest a specific method for natural pigment separation?
Natural pigment separation.
Yeah.
Anthocyanins and all. You can separate techniques they are asking.
Which is a specific technique for the natural pigment separation?
Natural pigment separation like anthocyanins and all maceration techniques we will normally go for. And like fractionation only we will do now. We will go for fractionation techniques.
So, any other methods for this natural pigment separations to enhance its stability?
To be honest, I'm not remembering now exactly.
How you enhance the stability of isolated pigments, ma'am? Natural
stability, yes. Yes, ma'am.
Isolated pigments. How you enhance the stability of isolated pigments?
Enhance the stability of the isolated pigments. Pigments. Pigments
Yeah.
are phytoconstants.
Yeah. No, pigments.
Pigments. We have to follow the standard procedure already available in the pharmacopoeias, and there will be some storage protocols that we need to follow for enhancing the stability. So the testing and the extraction, actually the herbal medicine suffer with lots of standardization disadvantages. So we need to follow the standard protocols or else we have to establish our own standardization method.
One more question is there, ma'am.
Yes, ma'am.
After collection of your sample, after its fractionation,
yes.
Whenever we go for preparative TLC, which types of mobile phases you have used for the preparative TLC?
The thin layer chromatography, what we have used for the column fractions, where we could see major spots in that. For example, 200 to 250 fraction, you are seeing two major parts. That particular solvent can be chosen. Little polarity dielectric constant should be less. For example, in the fraction, if it is chloroform methyl acetate 70-30, we have to start with 80-20. So we have to reduce the polarity and start once again the preparative. So and while we are going for preparative TLC, we should be very careful that we have to check the analytical TLC initially.
Initially. So not essential, it is always a methyl.
Otherwise, we will lose the compound present in that particular fraction. So we have to standardize the mobile phase based on the fraction mobile phase. For example, you are getting two spots with chloroform methyl acetate in a particular ratio. You have to do it 2 to 3 times and confirm the mobile phase and then again start.
And one more last question, ma'am.
Yes, ma'am.
How we can proceed for structural elucidations of phytoconstituents, particularly for secondary metabolites?
All these are secondary metabolites which are used in medicine. All these terpenoids, glycosides, tannins, phenols, everything are secondary metabolites. So the structural elucidation, we have to start with UV, IR, NMR and mass. So when we do polar fractions, we are getting in alcoholic fraction, some particular phytoconstant, you are getting UV spectra, you are getting at 2 peaks, that is characteristic for flavonoids. If you are able to see the pi to pi transition more, then you can say that aromatic benzenoid nucleus is present in your compound. And if you are seeing a non-polar fraction where you cannot see the UV absorption, it gives you an idea that long chain compounds are present in that. And in some cases, IR will give you that more number of phenolic OH present in that, which can be confirmed by the phytochemical test too, chemical test. And H1 NMR and C13 NMR by peak matching technique available with the genus literature, we can confirm to some extent, to major extent.
Ma'am, one last question from the participants. That is Rushabh Khandelwal. He is asking some book suggestions that can be used for botanical study.
Indian Ayurvedic plants by Kritika Basu. That is one standard textbook, which is available in volume 1 to volume 5. And then Materium Medica is there. And we have based on traditional or ethnobotanical means, these are the two references, ma'am, mostly.
Thank you, ma'am.
Thank you, ma'am.
I invite Ms. Akanksha Kasture to propose vote of thanks. Over to Akanksha.
Yes, ma'am.
Thank you.
A very good afternoon, our most versatile and dynamic guest, Dr. B. Geeta Ma'am, Professor and HOD, Department of Pharmaceutical Analysis, Shri Abhiram College of Pharmacy, Coimbatore. Respected Principal Dr. Sachidanand Angadi Sir, Yash Institute of Pharmacy, Aurangabad, and dear delegates, I, on behalf of Yash Institute of Pharmacy, its entire fraternity, and the organizing committee, I would like to thank our esteemed speaker who gave her vital time for her busy schedule to grace this webinar and sharing her knowledge on significance of phytochemical research in drug discovery. Thank you, ma'am, for sharing your giving valuable information about importance of natural products, how the phytoconstituents helps to treat the various diseases, various steps involved in phytoconstituent research, preliminary studies of drug discovery, innovation extraction method, isolation of phytoconstituents, significance of various chromatographic techniques, in vitro in studies, and also sharing tips and tricks in phytochemical research. Also thank you for clearing our doubts. This session will be very informative for all of us. I'm especially our principal, Dr. Chandra sir, for always providing opportunity to organize such events. Well, I thank you you all for being with us today and for attending this session very patiently. Thank you, everyone.
Thank you, Thank you, Akansha. As a token of love, ma'am, please accept this certificate of appreciation from Yash Institute of Pharmacy, Aurangabad.
Thank you, ma'am. Thank you, organizing team, and thank you, principal sir, for giving me this wonderful opportunity. Thank you, one and all.
Thank you once again, ma'am.
Okay.
Now,
Okay, ma'am.
Thank you, Kitaka. Yeah, the presentation was very nice.
Thank you.
Very informative. And
yeah, you have to support with good words. Then only I'll get inspired.
yes. So we are all missing you.
We do. We are also missing you, who will call me Akka. Okay, one brother is in Aurangabad, so I can meet you.
Yes, yes.
Convey my regards to your family, to ma'am, you are very sweet. To all of you, convey my regards. Thank you.
Thank you, definitely.
Thank you, thank you.
Thank you, ma'am.
Thank you, ma'am.
Now it's a time for approaching lunch. Next session will start at 2 p.m. All delegates are requested to join 10 minutes before the session starts. Thank you. Thank you very much.
Good afternoon, sir. Good afternoon, sir. Hello. Hello. Samsetti, sir. Good afternoon, sir.
Hello.
Good afternoon, sir. Hello. Hello.
Hello.
हाँ sir.
Hello.
Hello. Hello.
Hello.
हाँ आवाज येतोय sir.
Hello.
Hello.
Hello. Yuvraj sir.
हाँ sir. येतोय sir आवाज. Hello. 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 Hello.
Sir.
Hello.
Am I audible, sir?
Yes sir, audible.
Okay. Okay.
Sir थोडासा माईक जवळ घ्या फक्त.
Okay. Hello. Am I audible, sir?
Yes sir. Yes sir.
Okay.
तुम्हाला सर हा जो याच्यावरून तुम्हाला प्रेझेंट करणार आहे तुम्ही.
हाँ. Oh, एक मिनिट.
तुम्हाला प्रेझेंटेशन मोड जेव्हा प्रेझेंटेशन करायचं ना तेव्हा सांगा, म्हणजे तुम्हाला प्रेझेंटर करतो मी.
Just wait. I am joining from desktop.
Okay sir. Okay sir.
Yes, sir. I joined from PC also.
Yes sir. Yes sir.
Okay.
Can we start sir? Shall we start?
Yes. Yes. We can start.
Suvarna ma'am. Suvarna ma'am.
Yes, sir. Welcome. Welcome all the participants for day 1, session 3, session 3rd of 3 days national level webinar series on trends in pharmaceutical science and research jointly organized by Research, IQAC and IIC. Now, for third session, we have our eminent speaker, Dr. Jayaprakash Sangashetty sir, Associate Professor, YB Chavan College of Pharmacy, Aurangabad. Sir will talk on quality by design. I request Dr. Vandana Patil ma'am to introduce Dr. Jayaprakash Sangashetty sir.
Thank you, Suvarna. It gives me an immense pleasure to introduce Dr. Jayaprakash N. Sangashetty sir. Sir is presently working as an associate professor at YB Chavan College of Pharmacy, Aurangabad. He has completed his B.Pharm from YB Chavan College of Pharmacy, Aurangabad. Sir has completed his M.Pharm from Principal K.M. Kundanani College of Pharmacy, Mumbai. And Sir completed his doctoral degree from Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, under the guidance of Dr. Devanand Shinde Sir, former Vice Chancellor, Shivaji University, Kolhapur. He has around 19 years of professional experience. He is approved PhD guide of Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. And 6 students are working under him. He has 4 patents, 3 published, and 1 granted to his credit. He has published 235 research papers in international journals with a cumulative impact factor more than 400 and each index of 34. He authored 4 books. He has written 2 book chapters in books published by Nature, Springer and Bentham. His research work has received 3,610 citations. Sir is reviewer for more than 70 international journals. 5 of his research papers have been ranked by Science Direct as hottest 25 articles. Sir is recipient of Young Scientist Award from DST. He has successfully completed projects received from DST 25.52 lakhs, UGC 6.2 lakhs, and AICT 13.8 lakhs. One extramural research project from Sir 36.55 lakhs is in progress. He has received Best Paper Award from Elsewhere in 2015. He also has received Young Pharmacy Teacher Award from Maharashtra State APTI in 2015. Sir has also received YIP Best Publication Award in 2014. He has received P.D. Shetty Award for the Best Research Paper in 2009. Sir has guided more than 35 M.Pharm students. Sir is presently working as a member Board of Studies of Pharmacy at Shivaji University, Kolhapur. Sir is working as International Panel Member of Project Evaluation Committee of National Science Center, Polish Ministry of Science and Higher Education, Poland, since 2015 and evaluated number of projects. He is also working as a brand ambassador for Bentham Science Publisher since 2017. His major area of research include design and synthesis of bioactive molecules, development and validations of analytical method for drugs and pharmaceutical dosage forms, applications of quality by design in drug development and synthesis of polymer and their application in gene delivery system. Recently, he has been included in top 2% researchers list published by researchers of Stanford University for the year 2019 and 2020 consequently. So we have a great person with Dr. J. Sangashetty sir with us. Thank you.
Thank you, ma'am. Now I request Dr. Jayaprakash Sangashetty sir to start their session. Over to you, sir.
Okay. So, thank you, madam, for the introduction. Am I audible? Joshi sir.
Yes, sir. Audible.
Yes. So, very good afternoon to one and all. I'm here to give an overview of the concept, which is industry is in the transformation phase, and we are now going towards the era of quality by design. So, what exactly the quality by design is, and why we have adopted this particular science in the pharmacy. The basic objective of this particular lecture is to introduce the concept of quality by design to the new researchers who are willing to work in this area. And the more focus of this particular lecture will be on the analysis section, that is pharmaceutical analysis, how we can use this particular science in analytical method development. What are the advancements that took place in last, say, 1 decade, and what will be the future of analytical method development in the QBD framework, that is quality by design framework. So these are the some of the important points that I'm going to cover in this session. As far as pharmaceutical development is concerned, pharmaceutical development in last 3 decades had changed with number of aspects. So large number of changes have been done with the reference to the regulatory requirements. Now, whenever we are accepting something which is new to as far as development process is concerned, then there must be something which is having, we can say, limitations in the existing science. So new science is only considered or accepted only and only when we have the existing science with some limitations. To overcome the limitations of the existing science, new science will always play a significant role. Now, as far as quality by design is concerned, this particular science, which is existing science in the different streams of knowledge, we have adopted this particular science to overcome number of issues which were associated with the pharma regulation. As such, quality by design, this is the science which we have adopted from the engineering science. This science is well used or well explored in the engineering science since 1940s and 1950s. So what makes the pharma regulators to adopt this particular science? What were the issues associated with the pharma regulators as far as regulation in the pharmaceutical development is concerned? So all these aspects we are going to cover this particular session. Now, since we are concerned with the health of humans, so we are focused on the quality products. All the activities in the pharma sector are driven or directed or targeted towards one common motto, that is quality products. Now, the scenario in the industry which we are following is quality by testing. So yes, it is visible now.
Sir, visible.
Joshi sir.
Yes, sir. Visible, sir.
Hello.
Yes, it is visible.
Okay. Now, as such, the quality of pharmaceutical product is at the center point as far as pharmaceutical development is concerned. As I just now mentioned, all the activities which are going in the pharmaceutical development section, they are focused on quality pharmaceutical product. So as far as current approach is concerned, we are following quality by testing approach, where the decision about entire batch is taken after testing the quality at the end, and losses in terms of finance is one of the important issue. So once the batch gets rejected, then the pharmaceutical firm face a financial burden, and to avoid this particular new science we have adopted. Now, again, as I mentioned, what exactly this quality by design is. So this particular approach, it is a science-based approach, and basic important aspect in this quality by design is understanding any process. So success of any process, it all depends on how you understood the process. Unless and until you will understood the process, you will not be able to get an idea about where the defect in that process is. And this particular thought is well applicable in the pharmaceutical quality by design section. where this particular approach, it is a systematic approach that begins with the predefined objectives and emphasize the product and process understanding, and it all based on the sound science and quality risk management. So understanding the process, it is the prime requirement as far as pharmaceutical quality by design is concerned. Now, if you see the important features of this quality by design, so as I mentioned in the definition, it all depends on how well you understood the process. This quality by design, it identifies the characteristics that are critical quality. It translates them into attributes and how critical the process parameters can be varied. That is, it established that particular criticalness of the parameter, and the risk involved in the process will be reduced, and that is the most important aspect as far as quality by design is concerned. So this quality by design science, as I mentioned just now, this is the science which has been well explored by the engineering science since last 60-70 years. We have adopted this particular science to overcome number of issues which pharma regulators were facing, and implementation of this QBD, it is not a one-day process. This particular process has been started well in at the start of say 2000 or 2001. What is the basic difference between the current approach and quality by design approach? Some of the important points. So this particular approach which we are adopting now, it is based on understanding the process, whereas the current approach which we are using, it is based on testing the quality of the product at the end. Then the current approach, it requires the data intensive submission, whereas the QBD approach, it is a knowledge-rich submission. Current approach, it is based on the specifications are based on the batch history, whereas in case of QBD approach, the specifications are based on the product performance. Current approach, it is considered as a frozen process. Once the process or once we apply to any regulatory body, we cannot make the changes in the application. Whereas in case of QBD approach, we can make the changes. This process or this particular approach is comparatively flexible, and we can go for the changes even after application, provided the change must be within the design space. Now, the focus of current approach, it is on the reproducibility, whereas the focus on QBD approach is on the robustness parameter, which is the most important validation parameter, is well explored in the QBD approach, whereas we are performing the validation as a routine protocol in case of current approach. So QBD, it is more systematic development, whereas the current approach, it is empirical development. These are some of the important points that are differentiating between the current approach, which we are calling it as a quality by testing approach, and the approach which we are now shifting towards, it is QBD approach. Now, every science, it is based on some thought. This particular concept, it has been well defined by the quality expert Joseph Giron, and according to him, quality cannot be tested into the product, but it has to be built in by design. So rather than taking the decision about the quality of the product which we have developed after testing at the end, we have to develop the product with the desired quality. Now, initially, we have to define the quality or expectations from the product, and based on our expectation, we have to develop the product. So this is the basic concept, and this concept has been given by Giron, and quality by design, it is depending on the concept which he has given, and it has been further explored. Now, as far as pharma sector is concerned, why this concept has been accepted or adopted by pharma sector? So the history starts in 2000, where more than 5,000 supplements have been submitted by different pharmaceutical firms. And out of what is supplement? Supplement, it is additional document which is supplied by, or which is can say documented, or which has been submitted to the regulatory body, to the NDAs and ANDAs. So all these supplements, or evaluation of all these supplements by the regulatory body, it was a big problem. And to address this particular issue of large number of supplements, regulatory body were thinking to bring all the manufacturers on the common platform. To avoid the number of supplements to the original application, it is very much essential to bring all the manufacturers to design some common formats, to work on some common solutions, so that the original application should be submitted in such a way that there should be minimum supplements for any original application. And with that thought, they have decided to implement quality by design concept. But adopting a particular science at a sudden, it was not possible. We need to change the system stepwise, and for that they have started to implement this concept of quality by design with some minor steps. And the first step comes, it is in 2002, implementation of CGMP. It was the first step to implement quality by design. And this particular CGMP, it was considered as a CGMP for 21st century, and FDA has implemented certain changes in the pharmaceutical development to this. Again, after 2002, around 2004 and 5, PAT, that is process analytical technology, which is again a system for designing, analyzing, and controlling manufacturing process, which is totally based on understanding the process. And in 2005, US FDA has asked some of the pharmaceutical firms to submit their applications in a format of question-based review, that is QBR. And QBR, that is question-based review, it was the first step to implement or adopt quality by design principle in the pharmaceutical regulation. Now, after 2005, rather than forcing the pharmaceutical sector to implement this particular concept or implement or adopt this particular science, regulatory bodies have started to frame the guidelines, and these guidelines were in the forms of ICH guidelines. So ICH, again, it is the body which is responsible for framing the regulatory guidelines, which are quality guidelines, which we always call. Now, all the guidelines have been framed, and in 2008-9, ICH Q8, Q9, and Q10 have been framed, and these particular guidelines have been made available for the pharmaceutical developers. And these guidelines have been adopted by all the pharmaceutical sector for working on different sectors of the drug development. And in 2013, US FDA has made this concept of quality by design mandatory for all generic products. Again, after that, large number of we can say advancements have been taken place in this area. Number of amendments have been done in the original ICH guidelines. Number of ICH guidelines have been framed. Number of ICH guidelines are in the process of framing, and ICH has framed the different guidelines like 8, 9, 10, ICH 11, ICH 12, ICH 13, and now ICH 14. It is expected within 6 months, which is totally based on the quality guidelines required for analytical method development. So this is an historical perspective how this quality by design has been adopted. Now, the next era will be the era of quality by design. Different sectors of the pharmaceutical development will be under the QBD framework. Now, if we want to work in the drug development process, we must know what exactly this particular science is and how we can implement this science to the different sectors of the drug development. Now, as I mentioned just now, all the principles of QBD, regulatory bodies have implemented through ICH guidelines. Initially, when the concept has been introduced in the pharma sector in 2011-12, it was believed that QBD, it is again a compilation of ICH Q8, 9, and 10. Then people raised the question about what about the API development, since there were no specific guidelines related to API development. Then again, a concept paper about API development has been published by ICH, and ICH Q11 have been framed, and this particular ICH Q11 have been implemented in 2014, and these ICH Q11 were specific to the guidelines which are related to manufacturing of drug substance. Later on, there must be scope for development of the product throughout the life cycle of the product, it is generally said. And QBD is based on this life cycle management. And this concept of QBD, it has been documented in the form of ICH Q2. And this ICH Q2, again, after the concept paper and after suggestions which have been taken by the ICH from the different quality experts, this ICH Q12 has also been implemented. Before 6 months, again, this ICH Q13 has been implemented, and this particular ICH Q13 is based on the continuous manufacturing of drug substance and drug products, which is again the base of quality by design. Now, the next area where regulatory bodies are focusing about the analytical method development in the QBD framework. Now, what we need to do as far as analytical method development, as we all know, analytical method development, it is an integral part of drug development process. So without analysis, we cannot go further. So bringing analytical method development in the quality by design framework, it is one of the important challenge as far as regulatory bodies are concerned. Now, what protocol we are following as far as analytical method development is concerned, we are basically using the ICH Q2 guidelines. These guidelines are based on analytical method development and validation, and to some extent, the stability indicating assay methods. Now, these particular guidelines needs to be updated, and some of the important issues which are related with the quality by design adaptation, that issues needs to be addressed. 2018, a concept paper related to implementation of ICH Q14 has been published, and this concept paper, it is again available on the ICH website. This concept paper gives an idea about what should be the content of ICH Q14. Now, some of the researchers who are expert in the analytical QBD area, who have a good track record as far as analytical method developments and QBD, they are involved in framing these particular guidelines, and they have asked the suggestions. In last 2 years almost, some guidelines have been drafted and some guidelines are in the process. And it is expected that by the end of 2022, we can get these ICH Q14 guidelines. Now, in this particular lecture, what should be the content based on some previous literature, based on the people, the researchers who are actually involved in framing this ICH Q14. We will discuss all these important points and what important considerations are needed as far as ICH Q14 is concerned, because the researchers who have established their research in analytical QBD, they are involved in framing these ICH guidelines, and their views about implementation of QBD in analytical method development has been taken into consideration in the further slides. So this is all about what concept paper speaks about. This is the concept paper which has been published by ICH. So before implementing any guidelines, draft guidelines, a concept paper is published well in advance. This concept paper will give the actual picture, what should be the content, and they ask for the suggestions. And based on the suggestions and based on the expert opinions, they frame the guidelines. So this is the concept paper which specifically focus on improving ICH Q2, because ICH Q2 speaks only about the analytical method development with the routine instrumentations. As far as near IR is concerned, near IR, this is the advanced analytical tool which plays a significant role in new drug discovery. And very few things have been mentioned in ICH Q2, and that's why number of analytical tools needs to be improved in ICH Q2. So improving ICH Q2, it is again one of the important aspects in ICH Q14, and implementing some of the guidelines related to the analytical QBD in ICH Q14. That is the most important task, and this is the summary of this particular concept paper. It has been published by ICH in November 2018. Now, if you want to understand this particular concept, then we can divide this entire QBD concept into 5 to 6 different steps. As I mentioned just now, this concept, it is totally depending on understanding the process. If you want to apply QBD to any process, we need to understand this particular process. If you want to gain the control on that particular process, we need to understand the process. What exactly the process is, what are the different steps involved in the process, the success of that process, it all depends on how effectively each step gets success. The success of each step, it all depends on how effectively we will control all the parameters which are involved in the step of that particular process. So initially, as a part of quality by design, we need to understand the process. So initially, we have to define what is our objective, what we expect from that particular process. Once you define the objective, then the next step comes is, what are the important parameters that governs the success of the process? Then once you decide these are the important parameters which govern the success, then what are the parameters that requires more attention or that we consider the risky parameters? Once you mention all the parameters responsible for the success of that particular process, then we will segregate the risky parameters which affect the performance of the method or process. Once you identify the risky parameters or risky factors that affect the performance, then you will go for developing the experimental design. While designing the experiment, we have to consider the risky parameters which we have segregated in the initial step. Once you identify the risky parameters, once you develop experimental design, then implementation of control strategy, that is the most important parameter as far as QBD is concerned. And this is the process, this is the step, which is a key step as far as success of QBD in any pharmaceutical development sector is concerned. So in QBD, continuous improvement is needed. If you want to improve the process at any stage, we can improve that particular stage. And that's why a concept of design space comes into existence. Design space, it is a multidimensional combination of all the input variables, means any change in the design space is not considered as a change, and the issue related to supplement submission can be resolved using this quality by design technique. Now again, different analytical tools and use of QBD using this particular different analytical tools. Large number of attempts have been made by the researchers, and different researchers have used based on the concept, because as such there are no specific guidelines available for implementing quality by design in analytical tools. So we cannot say that these are the specific guidelines which are given the ICH, since no ICH guidelines are available for implementing QBD in analytical method. But based on the concept, based on the definition of quality by design, based on how effectively quality by design can be used, the different sectors of the drug development, people have tried to implement quality by design concept in different analytical tools. So from the literature, we can see that large number of analytical tools have been explored, like HPLC, LCMS, UPLC, capillary electrophoresis, Stahl-Fischer titration, etc. And again, for that, the concept of quality by design has been understood by the researchers, and they are again implementing this particular concept to the different analytical tools that have been present. Now, but as I mentioned just now, for implementing quality by design to the different analytical tools, specific guidelines are not available. Based on the knowledge or based on the concept of quality by design, how effectively it has been utilized or used for other drug development steps, people have used this particular tool for the above mentioned analytical tools. Now, as far as analytical method development is concerned, just now I spoke about the concept paper. A committee which has been appointed by ICH, which involves a number of researchers who have established their research in the pharmaceutical analysis, and they are heading the different analytical departments of number of companies. They are involved in framing these ICH guidelines, and I have taken some of the suggestions they have given in their previous literature. So one particular approach that has been suggested by Oaks et al. In 2011, he is a researcher who is working in GSK. He and his team, they have given one approach that is known as MDS approach. How we can implement this quality by design for analytical method development. For that, that was an initial attempt, because very few things were knowing about how effectively we can implement quality by design at that time. But he had tried to give some model so that how people can use this particular tool for analytical method development. And this approach he named as MDS, and this particular approach has been published in Journal of Pharmaceutical Sciences. Now, what this approach is, we will see in this particular slide. As I mentioned just now, quality by design is again depending on defining objective at the start, then again going for identifying the critical parameters, identifying the risk involved, minimizing the risk involved by experimental design, risking and risk identification, risk mitigation, and control strategy. These are the important aspects, and the same aspects have been considered by Oak et al. In 2011. He's the one person who is involved in framing the ICH guidelines, and that's why I have taken what he has suggested almost 11 years back. Probably reflection of his thoughts may be in the ICH guidelines. That's why I have taken this particular example. Now, what he suggested, as far as analytical method development is concerned, initially we have to define the method goal. What is your objective of that particular method? To what extent you want to measure? What are your expectations from the analytical method development? Then method scouting, which methodology you will use, which analytical tool you will use. Once you select the method, then what are the parameters that affect the performance of that particular method? Then once you identify the risk, then how you can gain the control by reducing the risk involved in the method. So once the method is developed in the QBD framework as per this MDS approach, then finally method validation, which is again a formality as far as analytical method development is concerned. If you go through all the steps which he has suggested, it is clearly an indication of the basic theory which has been suggested by quality by design approach. What basic theory is? Defining the objective at the start and working accordingly to achieve that particular objective. As far as analytical method development is concerned, what is the objective as far as analysis is concerned? What is the goal of the method which you want to use as a tool of analysis? That is very important. Once you define the goal, the next step comes is which method will helpful to achieve that goal. Once you decide what should be the method of analysis, then you have to go for what are the parameters that are risky as far as method success is concerned. Once you identify the risk involved in the method, then the next approach is reducing that risk or risk mitigation so that you can gain the control of the method. Once you gain the control of the method, ultimately the method becomes successful. And once you develop the successful method, then the last formality remains, that is validation. Now, there are different views, but the most common view is validation. It is not mandation. It is not mandatory as far as analytical method development in the QBD framework is concerned, because during development only, we are exploring robustness parameter as far as analytical method validation is concerned. Since robustness has been widely explored in QBD framework, method validation, it remains the formality according to Oak et al. And this particular fact has been further attested by a large number of researchers who have worked on this particular area. Now again, these are some of the important aspects that have been covered by Oak et al. In 2011. Defining method goal means defining an analytical target profile, which is nothing but an analytical ATP. It is a systematic approach. Goal or method intent needs to be defined, and some people named as an analytical target profile. So what analytical tool I am expecting? Once I define the analytical tool, what I am expecting from that analytical tool? So what are the requirements of the method? To what extent I need to measure? What should be the sensitivity of the method I am expecting? So all these things comes under this analytical target profile. Now, analytical target profile, it may be different for the different analyte. It may be different for the different analytical tools. It may be different for the different instrumentations also. Now, again, identifying some of the important parameters that affect the method performance. That is, we can say critical quality attributes. As far as analytical method development is concerned, CQA, that is critical quality attributes. Critical quality attributes in general, these are the parameters that affect the performance of that particular process. We are concerned with the analytical method or analytical process. So all the parameters that affect the performance of that particular analytical method are considered as a critical quality attributes, mostly in the pharmaceutical development section. Impurities are always considered as a CQA. Besides impurities, other parameters can be also considered as a CQA, but the most widely considered CQA is impurity as far as analytical method development is concerned. Now again, in method goal, what we expect? In method goal, method goal helps to decide what we want to measure, within what limit we want to measure. The answer of these two particular questions will help to define what is the objective of that particular method. So, to what extent we need to go in the depth of that particular analytical tool? So, what are the limits which we are expecting? To what level we want to measure and what to be measured and within what limit to be measured? These are the important questions, the answer of which will help to get the exact idea about what should be the method goal. As far as method design is concerned, again, a concept of design space which is given in original concept of quality by design. Okay. In that case, design space it is nothing but a multidimensional combination of parameters that affect the method performance. Now, again, all the parameters or all the variables or possible variables that affect more or less extent on the performance of the method that needs to be enlisted at the start. Once you enlist all the parameters, then the permutation and combination of all these parameters needs to be checked so that that particular method becomes more robust. As I mentioned just now, robustness parameter of the validation has been widely explored in case of quality by design. And here also in case of analytical method development, this robustness plays a significant role as just now mentioned. So identifying the parameters that affect the method performance that needs to be enlisted. Once you enlist all the parameters that can be varied, the performance of the method is depending on all the parameters. But among all the parameters that can be varied, some of the parameters are very risky and all such parameters needs to be segregated from the list. And that is very well known as a risk assessment. Once you assess the risk, minimizing risk is a challenge. And that is very much required to get the method a successful method. That's why in case of method design, multidimensional combination of all parameters that the method performance and which is nothing but a design space we need to give. And once you give the design space, any change which is given in the design space is not considered as a change as per the original concept given in the quality by design. The same concept is applicable in case of analytical method development, and probably in ICH guidelines, the definition of design space for HPLC or other types of instrumental techniques will be there, which will be different for the different instruments as per the method requirement. Now, again, while designing the method, large number of parameters needs to be considered, the reagents required, regional and geographical conditions, feasibility of the instruments, and for that, a decision tree can be prepared. Some prepares used to prepare the flowchart, how we can go for permutation and combination of all the parameters. Once the method has been chosen, basically you have to define the goal, to what you want to measure, to what level you want to measure. Then based on that, you will choose a method. Then once you choose the method again, then we have to enter in the depth of that particular method. If I have chosen HPLC, then what are the parameters that affect the performance of any HPLC method development? I have to enlist all the parameters among, for example, pH, temperature, column, own temperature, buffer, proportion of organic phases, etc., or flow rate, etc. Once I enlist all the parameters, then the next job comes about which parameters are majorly affecting the performance of the method. And then there comes the role of, we can say, risk mitigation. And based on the strategy which we follow for the risk mitigation, we can gain the control on the method, and gaining the control, the most significant aspect of analytical method development. Now, again, some of the important aspects. So method design also involves selection of different analytical techniques, as I just now mentioned. Among the various methods, suitable method to serve the desired purpose, based on your objective, based on the expectations from the method, you have to choose a suitable method. Sometimes, if you have chosen HPLC method, but HPLC with the UV detector cannot work, that case you have to go for HPLC with the PD detector. So again, choosing the method, it all depends on what is your objective and analyte under consideration. Now, I just now mentioned about what exactly this design space is. It is a multidimensional combination on an interaction of input variables, material attributes, and process parameters. So the material attributes are nothing but the properties of the analytes under consideration. What I am analyzing, that is also important. Whose analysis I am going to perform. So all the properties of analytes, if I am working on analyte X using one analytical tool, if I change analyte to Y, the analytical tool parameters may be different. And in that case, this particular design space will be different. So it is a multidimensional combination and interaction of input variables. So all the input variables, which includes material attributes, that is the properties of analyte under consideration. And the process parameters, if I have chosen any analytical tool, then working on that particular analytical method is a process. All the variables in that particular process are the process variables. I have to consider all these process variables. I have to consider the properties of the analytes, and a combination of all these parameters, it gives a concept known as design space, and the definition of which has been given in ICH-Q8. This is again in ICH-Q8, Q9, and Q10. This the basic concept about the quality by design has been given, as I just now mentioned. Then different types of experimental designs that we can use, full factorial, then fractional, and other tools that So what is critical quality attributes? Critical quality attributes are the factors that affect the quality and safety of the products that are first sorted out, and its possible effect on the method development is studied. Now, CQA in case of formulation development are totally different than the CQAs in case of analytical method development. What quality by design is? It is based on a process. If the process is changed, the CQAs will be changed, as I mentioned just now. So, if we are working on any process, CQAs in case of that particular process are totally different if you are working on any, say, a product. Now, if the drug product contains an impurity, in case of analysis, so CQAs are different, as I just now mentioned. Impurities are always considered as the most important CQAs. Besides impurities, large number of process variables are also considered as a CQAs in case of analytical method development. Am I audible? Hello?
Yes, sir, you're audible.
Now, what is risk assessment? Assessing the risk involved. That is the most important aspect as far as success of any analytical method development is concerned. How effectively we can analyze what is the risk involved in the process. The success of any method, it all depends on identification of the risk involved in the process. Once you identify the risk, then only we can gain the control on the process. That is the important aspect. So gaining control on the process, if you want to effectively develop the process, that is the most important thing. Now, as based on the literature available, different analytical tools or different assessment tools are available, which includes Ishikawa fishbone diagram, then FMEA and Pareto analysis. If you go through the literature, in past, all these tools have been successfully used, and these tools may be the part of ICH-Q14, which are expected by the end of December 2022. Now, once you identify the risk involved, then the next job is we have to segregate the parameters which we have identified as the risky parameters. So segregation of parameters, suppose out of the parameters, the 10 parameters, if you find that there are 6 parameters which are considered as an risky parameters, then segregation of this risky parameter is another important tool that has been considered by OAK in 2011. And he has classified, or he has differentiated all these parameters into high risky parameters and low risky parameters. And he has given the more focus on high risky parameters. Again, this particular part, which may be again the part of ICH Q14, because he has given more stress on how the equipment which you are using is qualified. And for that, he has given the focus on method qualification, out of which MIQ, that is method installation qualification, operational qualification, and performance qualification. These are the 3 important aspects. And installation qualification, it is the part of an installer. That's why more focus he has given on operational qualification and performance qualification. And based on that, different parameters he has suggested. So these are the parameters, that is operational qualification and performance qualification, which involves injector, auto sampler, solvent delivery system, detector, and column mount temperature, and what parameters needs to be considered if you want to use a specific equipment for this particular purpose. Now, as I mentioned, gaining control of the process is very important. So planning control strategy is very important, and for that we need to identify more risky parameters in this case. So a factor has been identified, which has been identified as a high risky factor, needs to be controlled. And for gaining the control again, we have to go for the control strategy. And this particular control strategy plays a significant role, and it has been named as a risk mitigation. Once you reduce the risk involved in the process, then you have successfully gained the control on the process. Then the method has been successfully developed. Now, once the method has been successfully developed, then as initially just now mentioned, that validation, whether we can go for validation or not, again there is a debate going on in this particular aspect, but majority of the researchers are suggesting that validation should not be mandatory if you have developed the analytical method in the QBD framework, because we are exploring robustness parameter in QBD. That's why a spatial validation need not be the part of analytical method development, and that's why once you develop analytical method in QBD framework, then validation should not be the compulsory part, which is expected in ICH Q14 also. So it is generally said that validation, it is a checkbox tool, and it should not be the method intent or method objective. In case of ICH Q2, validation was mandatory, because once you develop the method as per ICH Q2, we have to validate as per ICH Q2. But if these particular ICH guidelines will come, then validation may remain as a formality based on the previous literature, we can say. So as per the MDS approach, these are some of the expectations which will be there in the, we can say, ICH guidelines, because the researcher group, that is worked at all, they are part of this ICH framing group, and hopefully some of the suggestions which they have given in 2011 may be the part of ICH guideline, that is ICH Q14. Again, another suggestion or another work which has been published by researchers in Pfizer, and they have given a QBD workflow, that is analytical QBD workflow. And this particular research group, they have given the concept in a different way. They have given the different terminologies. The concept of quality by design remains same. Means initially defining the objective, okay, then identifying the parameters, that is critical quality attributes, segregating the risky parameters, reducing the risk involved, and gaining the control on the method, continuous improvement. All these concepts which are there in the original concept of quality by design remain same in analytical method development also, but they have used the different terminologies. So according to this group, this particular data they have published in 2013 again in the Journal of Pharmaceutical Sciences, and they have named it as an AQBD workflow. Specifically, the more focus has been given on HPLC, and I'm coming in the next part of this particular presentation. Initially, they have defined this method objective as an ATP, that is analytical target profile, where defining method requirements and performance criteria, Then the next step comes to this analytical technique selections, which will we can say in accordance with the ATP. Then systematic method development. Then performing the risk assessment, de-risking using design of experimentation, and framing the area, which we were calling it as an design space in the previous case. They have been renamed as an method operable design vision. The MODR, which has been named by this particular group, is similar to the design space, which is the concept which has been given in the original QBD. So again, there is a continuous scope for continuous improvement. We can improve the method throughout the life cycle, and life cycle improvement, it is one of the important aspects as far as AQD workflow is concerned. Again, to summarize this, they have considered this particular group, that is George Reed et al. They have given this concept in case of HPLC. They have considered HPLC method development into different waves. If you want to go for a particular HPLC method development, then we have to initially consider the individual step as a single wave. At the start of HPLC method development, we must have a primary knowledge about the analyte under consideration, analyte whose analysis is to be carried out, and we have to define the ATP, that is analytical target profile, based on the requirement from that particular analysis. Initially, we have to plot the graph between log D versus pH. Then you have to go for the wave 1, in which the information about the stationary phase, solvent, pH, organic ratio of organic phase, and then you have to go for the suitable column selection based on the requirement of the method, whether we can go for C8, C18, or what are the method requirements, whether the UV detector works or any other detector needs to be used. Then you have to go for optimization in wave 2, that is narrowing the pH. Then in wave 3, we have to go for the temperature changes and gradient screening. And lastly, you have to draft the conditions. So this is one example. Practically understood this entire method development using HPLC in this 1 hour session is impossible. But I have given some of the examples, and you can refer these particular articles, those who want to work on HPLC method development in QBD framework. And for them, this particular article plays a significant, important role in order to understand the concept. If you want to work on HPLC method development, if you understood this particular AQD workflow, then it will be a bit easy to work in this area. Now, what is the summary of AQD workflow? It starts with understanding. As I mentioned at the start, QBD, it is nothing but understanding the process. If you understood the process, you can identify the different risky steps involved in the process. Ultimately, you can gain the control on the process. And in a similar way, AQBD workflow, it is again depending based on understanding the analytical method development, method needs, method technique selection, selection of initial chromatographic conditions, refinement of these conditions, risk assessment, and de-risking, that is risk mitigation. So overall, these two approaches that have been suggested by the key researchers working in the area and who are directly and indirectly involved in framing these ICH guidelines, and based on their views, which has been published in the literature, we can see that large number of aspects that we have just now covered, they may be the part of ICH Q14, and which is expected, as I just now mentioned, in 2022. Now, understanding analytical method development in limited time framework, it is practically impossible, as I just now mentioned. But if any researcher wants to start work on analytical QBD, then for them, I have taken one example, which is an in-house analytical method development that we have worked on this particular any drug, single drug. How we can start with HPLC method development for any drug, a single drug without consideration of any formulation. We can go for impurity profiling under QBD environment. We can go for advanced analytical tools or hyphenated tools using QBD framework. But for understanding, we should know what exactly we have to follow a QBD framework for analytical method development. What should be the approach towards AQBD? For that, I have taken an example. Now, If you want to work on any one drug, so this is the example where we have worked on analytical method development for a drug that is fingolimod. It's a drug which is used in the multiple sclerosis. So based on the literature survey, we have chosen the drug. Very few analytical tools were available at that time. We have worked, say, 5 to 6 years back on this particular drug. Based on the concept of, based on the guidelines given in ICH-Q2, we have started for initial literature, but we thought that if you apply QBD for analytical method development, then based on the literature available at that time, we have proceeded. Now, if you want to start with this, so this is a work plan, how we can start. Literature survey, we have to select the drug, then you have to define the analytical target profile, which is again a part of first approach, which has been suggested by Oak et al. Now, for defining the analytical target profile, it again differs on method requirement. If you want to work on one single drug, analytical target profile will be different. If you want to work on simultaneous estimation of the two drugs, then analytical target profile will be different. If you want to work on the different analytical tools other than HPLC, the analytical target profile will be different. So defining analytical target profile is very important. Qualifying the instrumentation, which is again the suggestion given by Oak et al. In 2011, which may or may not be the part of ICH guideline in future. Then identifying the risk, then reducing the risk, okay, and method design, and lastly, a validation as a checkbox tool, not as a method intent, will be the last step. So this is the drug that we have chosen, and this fingolimod that I just now mentioned, it is a drug which is used in the multiple sclerosis. And initially, if you want to start with this analytical method development, so this will be the guideline. I have given one example for the researchers who want to start the work in analytical method development using QBD. Based on the previous literature, based on the history of the drug, different analytical tool data available with that particular drug, we have initially chosen a mobile phase, and initial chromatographic conditions we have adopted. So later on, we have selected a wavelength. By scanning in the UV region, we found 218 as an wavelength, which is the lambda max for that particular drug. Then we have defined the method requirements, that is analytical target profile. So our objective was to develop HPLC method for the fingolimod, which is a robust method, which is accurate, precise, and as far as specific requirements are concerned, USP tailing less than 1.2, number of theoretical plates as per the requirement, short analysis time less than 10 minutes. All these are the requirements that we set. Out of all these requirements, if you could achieve one or two, okay. At that time, much guidelines were not available. So whatever the data we had at that time, we have proceeded with that particular data. Now again, instrument qualification, which is again, I just now mentioned which parameters can be used as a instrument qualification. We have checked the qualification, how instrument is qualified with these particular parameters, and we have followed the procedure. Then we have carried out the risk assessment, and based on the risk assessment, this data has been generated. An initial chromatographic condition. Initial chromatographic condition we have carried out using C18 column, and mobile phase we have tried is methanol water, and then we have shifted towards methanol and potassium phosphate with pH 4.6. So this is a chromatographic condition, ammonium formate in the ratio of 70-30, wavelength 218, flow rate 1.3, and retention time 5.25. It was the initial chromatographic condition based on the history of that particular drug. And we want to perform this analysis in the QBD framework. The optimized condition which we will get at the end of the analysis, it may be same or it may be different, and we have proceeded with. So we have designed the, we have gone for the method design. The optimization we have done by response surface methodology, and we have identified the 3 parameters. Before this, we have initially identified the risky parameters. So pH, flow rate, and methanol concentration. Initial screening we have done using Plackett-Berman that I have not mentioned here. So Plackett-Berman helps to identify our more risky parameters. So once initially optimization has been done, then we have gone for the final optimization using Box-Bacon. Then we have considered USP tailing as the response, and only one response has been considered. In advanced tools, we can consider 2 responses. If 2 drugs are there, the response may be the resolution between the 2 peaks. If impurity is there, the response between the resolution and the drug, the resolution between the drug and impurity may be the response. So response may be varied based on the method requirement. So we have chosen this particular USP tailing as a response here, and final optimization considering these 3 parameters, that is pH, flow rate, and methanol concentration, we have carried out. Again, this is the design which we have developed, that is box Baker design. We have carried out the analysis for the 16 runs, and based on the data which we generated, the optimized method has been developed, and this particular method has been validated as per ICH guidelines. Now, again, as far as the result part is concerned, so this is again instrument qualification, method design. So all the parameters which we have segregated have been optimized initially using Blackett-Berman. The more critical parameters have been then subjected for the box Baker design, and selection of the parameter, it is again based on the Pareto charts. This particular listing of parameters is very important. Once you select these particular parameters, you can go for the further optimization using box Baker response surface diagrams, in which the 2 parameters have been kept constant. 1 parameter has been kept constant and 2 parameters have been varied, and we have considered a USP tailing as a response in this case, and based on the response surface diagram, the final optimization has been done, and we get the optimized condition based on the p-value, and p-value decides the optimized conditions. Now, this is the chromatogram of optimized condition. Now, this optimized condition, it may be the same or it may be different than the initial chromatographic conditions. Now, validation remains a formality, as I mentioned just now. In case of analytical method development in the QBD framework, validation remains the formality because it is considered as a checkbox tool rather than the method intent. Method intent is we have to develop the method as per the objective of our requirements. Validation, it is an additional checkbox tool in case of QBD framework. Now, this is the example which I have given for the single drug. If we want to go for a multi-drug combination, the resolution between the drugs may be the response. If you want to go for impurity profiling, the resolution between the drug and the impurity may be the additional response. You can consider more than 2 responses also. We can go for the analytical method development. Besides HPLC, we can apply this quality by design to any pharmaceutical development whereby a process understanding plays a significant role. Now, in conclusion, what QBD is, it involves the thorough understanding of the process. The basis behind the success of any process, it depends on how effectively you have understood the process. Once you understood the process, we need to understand what are the important parameters that govern the success of that particular process. Once you know what are the parameters that govern the success of the process, then we need to control on these particular parameters. QBD is based on same thought. So thorough understanding of the process is the key requirement for QBD. It is a regulatory requirement. Now, we have to develop a design space. Moving within the design space doesn't require the post-approval changes. And the issue which is related with the supplement applications as to most extent can be solved using this QBD tool. So, as I mentioned, slowly regulatory bodies are implementing a quality by design tool to the different sections of the drug development. Initially, they have made it mandatory for the generic products. Slowly, through the ICH guidelines, they are implementing quality by design tool to the different sections of the drug development. And ICH Q14, which we speak about right now, it may be expected by the end of 2022. And based on the previous literature, based on the concept paper which has been published in 2018, we can see that most of the points that we have discussed just now may be the part of ICH Q14. Again, these are some of the publications related to quality by design. This particular review we have published in 2014, where very few information about quality by design was available at that time. We have summarized this particular data and we have presented that particular data in the form of review. And this particular review, it serves as an important guideline for the researchers who want to work in this particular area. And large number of citations are received to this particular article because much literature was not available at that time, where in 2014 it has been published, and you can see that large number of researchers are referring this article. Using this analytical tool, we have published again one article for simultaneous estimation of the two drugs, where we have considered the resolution between the lopinavir and ritonavir, an important we can say response that I just now mentioned. And whatever the work we have carried out, encouraged by some of the we can say important aspects we enter into. We wrote the book on this particular quality by design in 2014-15, and again it has received much attention by the pharma fraternity, and this is the first book in pharma academics based on this particular concept, which we have published in 2014. Again, at the end, I'm thankful to my research guide, because of whom I am in front of you, because most of the things I learned because of him only. Again, thankful to my teacher, Dr. Angadi sir, who has given an opportunity to interact with you. Lastly, Dr. Abubakar sir, who is in charge principal of YIP Aurangabad College of Pharmacy, who permitted me to interact with you. So thank you. Again, the topic is open for the discussion. If you want to ask anything, you can ask.
Thank you, sir. Thank you very much, sir, for your valuable and informative session on quality by design. Sir, I'm sure your address will help our participants in their research work.
Yes, sir.
So there are questions. Sir. Am I audible, sir?
Hello.
Hello, sir.
Sanga Shetty, sir. Hello. Hello. Sanga Shetty, sir.
Dear participants, a feedback link will be will be floated in the chat box. Okay, so all the participants are requested to fill the feedback form for day 1.
Madam, sir is waiting for question answer session.
Okay. Yes, sir. Sir, there is a question for you. If we follow process design by quality QBD approach, is there a need of any analytical method validation as per ICH guideline? Sanga Shetty, sir.
Hello, sir. Hello. Hello, sir. Hello. Hello. Hello.
जोशी सर, हॅलो.
येतोय सर, आवाज येतोय.
हॅलो,
आवाज
जोशी
येतोय
सर.
येतोय आवाज. आवाज येतोय सर. हॅलो हॅलो, आवाज येतोय. संगा शेट्टी सर, बोला. सर लगाओ ना फोन एक बार. नहीं आ रहा ना तुम्हें. हेलो 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 सर लगा क्या फोन.
Swarna ma'am, am I audible?
एक देशपांडे मॅडम, एक 2 मिनिटं थांबा.
Okay.
हॅलो, संगा शेट्टी सर. हॅलो
हॅलो.
हा, येतोय सर आवाज. आवाज येतोय सर.
हॅलो.
हॅलो 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 हॅलो
हॅलो.
येतोय सर आवाज.
Yes, yes. Please ask the questions. I have gone through one question from the chat.
Yes sir.
Okay, the question is why validation is formality as far as QBD framework is concerned. Okay, so I just now mentioned that in case of analytical method development, we are developing the method and then we are going for the validation parameters like sensitivity, accuracy, precision, or robustness. But since in case of quality by design, method development or method is developed itself by exploring the parameters which we usually explore in the robustness, and that's why no additional validation is required, and that is the thought which has been given in the two literatures that we discussed. So till date validation remains a formality as far as analytical method development is concerned, unless and until these particular guidelines which are expected by the end of 2022, these guidelines will specifically mention about some of the validations are required. Till date, based on the literatures where we can say that since in QBD we are exploring robustness parameter to wider extent, no specific validation parameters needs to be explored in QBD framework. Anything else?
Sir, which are the parameters? Which are those parameters?
Yes. Hello.
Sir, which are the parameters for analytical method validation if you follow the QBD approach?
No, till date, with the available literature, specific validation parameters are not required. There is no need to go for special validation if you develop the method under QBD framework, as per the current literature. But if in the ICH, if they mention about some of the parameters, because no regulatory guidelines are available till date, we are working in analytical QBD based on the available literature. So as I just now mentioned that in QBD environment, we are developing the analytical method by exploring robustness thoroughly. So again, after development, whatever the condition or experimental condition or actual design condition we are getting, that condition itself is self-validated. तो जो experimental condition हम develop करते हैं तो वो develop condition is self-validated है, so no special validation is required. Yes.
Okay, sir. Thank you, sir.
Anything else?
No, sir. Okay. Thank you. Thank you very much, sir, for your valuable and informative session on quality by design. I'm sure your address will help our participants in their research work. Now, as a token of appreciation, sir, I request you to accept appreciation certificate on behalf of Yash Institute of Pharmacy, Aurangabad. Rekha, ma'am.
Thank you. Thank you.
Okay. Before we move towards concluding session of our day 1, that is vote of thanks, there is an important announcement for all the delegates or participants. Now I request Dipali Kulkarni ma'am to announce. Over to you, Dipali ma'am.
Thank you, Suvarna ma'am. Sorry for some technical errors are there. That's why appreciation certificate of Dr. Samshetty sir was not displaying in the screen. So I request Rekha ma'am kindly turn off her sharing screen. So sir, this is our token of love and certificate of appreciation.
Thank you, madam.
Okay, so one important announcement for our delegates and participants. Very good afternoon, Galaxy of Intellectual. Hope all of you are enjoying the session. We are happy to announce that as we are receiving some suggestions from the eminent speakers, we are going to launch 2 different competitions which are to be carried out after completion of this national level webinar series, that is Trends in Pharmaceutical Science and Research. Today, we are blessed with presence of many participants across the nation. Participants with wide range varying from undergraduate students postgraduate students, research scholars, faculty members, and industrial representatives. So without taking much more time, let me announce those competitions. First competition is post-webinar series idea competition, and second competition is innovative adaptation competition. The registered participant for this national level webinar series are eligible for participation in both the competitions.
You have unmuted call.
You are expected to write a short review in the form of either PowerPoint presentation or a video by using your innovative ideas and creativity. You will be those ideas and creativities which you will be applied in the future, and those ideas which will be adapted by you after hearing these 3 days full packed brainstorming sessions. Link for the submission of ideas and innovative adaptation will be float in the chat box during valedictory session. Best ideas and innovative adaptations will be selected by team of experts which is composed by Institutions Innovation Council. Winners are categorized in 2 categories. One category is from student category and second one is non-student category. Both the competitions will be awarded with cash prizes of 2,000 and 1,000 respectively. So wish you very happy learning and knowledgeable sessions ahead. Thank you very much, and over to you, Suvarna ma'am.
Thank you, Dipali ma'am. Now I request Ms. Renuka Sonone to propose vote of thanks. Over to you.
Good afternoon, everyone. Honorable guest speaker, Dr. Jaiprakash Sangasetti sir, Associate Professor, YB Chavan College of Pharmacy, Anand Angdi sir, Yash Institute of Pharmacy, Aurangabad, and dear delegates. On behalf of Yash Institute of Pharmacy, its entire fraternity, and the organizing committee, I feel immense pleasure to take this opportunity to propose vote of thanks to our eminent speaker, Dr. Jaiprakash Sangasetti sir, who spared the time from his busy schedule to grace the webinar with his extremely relevant address on quality by design. Thank you so much, sir, for teaching us quality by design right from its historical background to its validation. After this webinar, we have a good knowledge of the implementation of the analytical tools and analytical method development. You significantly explained the critical quality and risk management with AQBD workflow too, and it will surely help us in our future. I would specifically I would specially express regards and gratitude to our principal, Dr. Angdi sir, for always encouraging us and providing opportunities to organize events. My deep sense of appreciation and thanks to all the esteemed delegates who chose to live with us and attended the day 1 of webinar with great enthusiasm and made it a successful event. My sincere gratitude also goes to the organizing committee for working hard for the past few days to make this webinar successful. Last but not the least, I thank our technical team for their timely support to resolve technical issues during the webinar. Once again, I thank you all for being with us. Thank you, everyone.
Thank you, Renuka. So tomorrow, that is day 2 of national level webinar series on Trends in Pharmaceutical Science and Research, jointly organized by Research, IQAC and IIC, will start at 10:30 a.m. All the participants are requested to join the session 10 minutes before the commencement of the session. With this, I conclude that today's session is over. Thank you all of you.